Hello there and welcome to the planet's memory, where curiosity moves at a gentle pace and science sinks slow and unhurried into mystery. Tonight we're going to take a long, steady drift into one of the oldest questions hidden in the waters of this world. A question that seems almost like a dream. What if the ocean remembers? Not in words, not in symbols carved on stone or ink pressed into parchment, but in the invisible records of temperature, in the long trails of salt, in the heavy circulation of currents that have never stopped moving since before there were eyes to see them. The ocean may be not only the diary of Earth, but its clock as well, keeping time in ways we cannot touch, measuring ages not by years but by layers of silence. Think of how a drop of water moves. It falls as rain, slides into a stream, drifts into a river, and finally enters the sea. From that moment, its journey can last weeks or thousands of years, circling in pathways vast enough to outlive cities, empires, even civilizations themselves. In the deep Atlantic, waters sink and slide slowly southward, not to return to the surface sunlight again for centuries. Down there, in darkness cold enough to preserve secrets, the ocean is still holding on to memories of climates long since gone. Within the quiet drift of each molecule, there is a trace of when it last touched the air, a chemical signature, like the faintest handwriting of the sky. Scientists call them isotopes, tiny variations in oxygen or carbon, that act like bookmarks in Earth's unfolding story. To read them is to discover that the sea itself has been keeping track, faithfully, without ever meaning to. If we follow that water deeper, we find places where memory and decay merge. Along the jagged seams of trenches, whole slabs of ocean floor are pulled beneath the continents, carrying with them the layered sediments of forgotten times. Fossils, shells, even the dust of vanished forests, pressed into stone, buried, reheated, remade. Nothing is discarded. It does not vanish. It is recycled into the mantle of the planet, erased on the surface but still folded into Earth's shifting body. Could it be that the ocean knows more about the past than we do, because it has swallowed it all? Every vanished coastline, every drowned valley, every breath the atmosphere has ever given away, swept into a patient archive where time is stretched and diffused until memory becomes less an event and more a temperature gradient, a slow chant spoken in salt. And yet, this memory is fragile. A shift in currents, a change in wind, a release of heat from far away can rewrite centuries of stored rhythm. The North Atlantic, with its slow pulse of overturning water, is a kind of heartbeat for the climate we live within. If it slows, if it alters, the whole Earth shivers, continents dry and flood, ice sheets grow or collapse. This is not myth, not story. It has happened before many times. The record lies in the seabed muds, in the cores drilled from floating ice, in the subtle chemistry of bubbles of ancient air. Looking at them is like looking into the unconscious of the planet, where memory merges with dream, where cause and effect loop endlessly. There's something haunting in the thought that the ocean does not just host life but absorbs the trace of everything life has ever been. Perhaps the earliest microorganisms, dissolving into ancient seas, left chemical trails that still circulate in deep gyres we have yet to measure. Perhaps voices, thunder, even the smallest ripple of sound remains for a while, carried down into thermoclines, refracted and stretched so that a song from centuries ago might still be faintly vibrating somewhere in the Pacific night. Maybe, or maybe not. But what if memory does not require permanence at all? What if remembering is not about keeping detail, but about carrying the pattern long enough for it to echo into something else? When you stand by the water, even a quiet pond, you may feel it. A kind of patience too vast to be fully grasped, an existence that is slower and older than ours. Every tide feels familiar, like a breath you've taken before but from very far away. Maybe what pulls us to the waves is not only beauty or danger, but recognition. Somewhere, deeply buried in our ancestry, we too were carried in those tides, and perhaps the ocean remembers us just as we are trying to remember it. And yet, if water can hold on this long, if it can cradle the weight of lost climates, ancient forests, forgotten winds, then a question lingers like salt on the air. If this much can be remembered by something as fluid and shifting as the sea, what else might still be held, hidden, submerged, waiting for us. Not in the water itself, but beneath it. What else might have been forgotten, or perhaps never forgotten at all? And yet, if this much can be lost, what else might we have forgotten? Perhaps we have overlooked the simplest truth of all, that the ocean does not only carry memory in its salt and silence, but also in the way it breathes. For beneath the rolling waves lies an endless exchange, so slow and so steady that it feels almost invisible. The trading of gases between sea and sky, oxygen, carbon dioxide, nitrogen, all of them passing quietly over the boundary where air touches water, where molecules slip between worlds without notice. It is through this quiet breath that the planet regulates itself, not with noise or urgency, but with rhythms that extend beyond the horizon of any single human life. When you inhale right now, it is almost certain that a part of the oxygen filling your lungs once came from the ocean. Not just from the surface waves, but from life itself, drifting in the upper layers of sunlight. Phytoplankton, small as dust yet numerous enough to paint whole regions of sea into shades of green and blue. With every pulse of light, they take in carbon and release oxygen, producing not in bursts but in a constant, patient flow. Some of that oxygen finds its way into the atmosphere, where winds may scatter it for months or years before it finally brushes against us, silent and unrecognized. Every breath we ever take is braided with the echoes of those ancient photosynthetic whispers. But this exchange does not work in one direction. The ocean also draws in gases, pulling carbon dioxide from the atmosphere and dissolving it into its depths. Some of it drifts into chemical equilibrium with carbonate, becoming part of the invisible chemistry that builds shells and skeletons. Some of it sinks deeper still, following the same currents that carry memory, locked away where centuries or millennia will pass before it emerges again. If we could trace one exhalation of a forgotten ancestor, one random sigh from thousands of years ago, could it be lingering even now, dissolved in the deep Pacific, waiting to rejoin the sky? Maybe, maybe not. But the possibility itself is haunting, that the breath of the past has never truly left us. What if the ocean's respiration is not only about gases but about balance? When carbon dioxide becomes too strong in the atmosphere, the ocean swallows more of it. When oxygen rises, parts of the ocean hold back its release. It's not a conscious choice, but a physics as delicate as it is immense, a negotiation written into molecules and currents. And yet there are limits. The chemistry of seawater shifts as more carbon is absorbed, growing more acidic, rearranging the building blocks of life that depend on calcium. As corals dissolve, as shells thin, as plankton falter, the breath itself begins to change. Could it be that we are now hearing the strain in the ocean's quiet breathing, a faint unevenness in a rhythm we once thought eternal? To imagine the ocean breathing is to imagine time on scales far beyond us. We measure in hours and days. The sea exhales in centuries. Great volumes of carbon are pulled down during glacial ages and released slowly back into the air over interglacial spans. Long after a civilization collapses, long after languages vanish, the ocean continues its inhalation and exhalation, reshaping the atmosphere as if sculpting with invisible hands. Even entropy, the slow tendency of order to dissolve into disorder, is slowed within these cycles, as the ocean takes the chaos of rising gases and gives them back as balance, never identical but still in rhythm. And so when we breathe, is it too much to say we are breathing with the sea? Not because we chose to, not because we notice, but because this is the quiet architecture of life. Perhaps when you fall asleep tonight, lungs rising and falling, you are unknowingly synchronized with the distant sway of tides, aligned not with the clock at your bedside, but with the vast metronome of an ocean's inner tide. There is comfort and a kind of humility in remembering that our tiniest actions, our smallest exhales, are traced back into this endless conversation between water and air. We are a part of the cycle. We are participants in the breath beneath waves. And yet, if the ocean's respiration holds this much power, soft as it seems, what does it mean for the forgotten eras when the atmosphere itself was different? What might the ocean have witnessed and inhaled and released again across the epochs when oxygen was scarce or when carbon drowned the skies? If it remembers the breath of ancient worlds, then what other traces might still be whispered under the surface, waiting to return? If it remembers the breath of ancient worlds, then what other traces might still be whispered under the surface, waiting to return? Perhaps the answer is carried not in the gases themselves, but in the pathways that move them. For the ocean is not still. It circulates, it drifts, it flows, and though it may look like endless water from above, inside it is threaded with a living motion, a circulation as vital to Earth as blood is to the body. Deep currents move heat and salt and memory across the basins, stitching together pole and equator, smoothing the edges of seasons into the long curves of centuries. This global conveyor, as it is often called, might be the planet's longest heartbeat, one that beats so slowly we almost cannot hear it, and yet it guides the climate of every moment we inhabit. Imagine a single parcel of water, cooled near the pole until it grows heavy enough to sink. Once beneath the surface, it begins a journey that will last longer than empires. It will slip southward through the Atlantic, round the bend of Africa, stir into the Indian Ocean, pass into the vastness of the Pacific, and there, perhaps, quietly rise again to meet the sky after centuries have passed. The scale is almost unthinkable. A single loop of circulation can take hundreds, even 1,000 years. And as this water flows, it is not empty. It carries the breath of carbon dioxide drawn long ago, the faint warmth of a forgotten summer, the minerals and isotopes shaken loose from the continents. To drift with it is to travel inside Earth's memory, to be folded into the long pulse of planetary time. We think of time as linear, but here it loops. One circulation repeats after another, like a ghostly circle traced again and again in slow-motion ink. What fell as snow at the pole becomes the cool driver of the conveyor. What evaporated at the equator becomes the trigger for the winds that help push it forward. Salt, heat, wind, gravity, they are like valves in this hidden artery, keeping the flow alive, ensuring that warmth is shuttled northward, cold is swept southward, and no part of the ocean is left untouched by the rest. Is it possible that this is the closest thing Earth has to a nervous system, pulsing not with electricity but with moving water? Maybe, maybe not. But the metaphor lingers, like a rhythm that can be felt, even if we do not know where it begins or ends. If these currents are Earth's arteries, then what happens when they falter? In the past, the conveyor has slowed, even stopped, rewritten by melting ice or shifting winds. And when it did, climates unraveled. In some forgotten age, northern Europe froze while deserts bloomed in unexpected places. Forests withdrew. Animals wandered or vanished. All because the heartbeat stumbled. The planet's pulse is delicate, yet vast. Its failure can appear in geological scars, in isotope shifts, in the growth rings of petrified trees. Scientists peer at these traces the way one might study the pulse of a patient, fragile and mighty all at once, knowing how much depends on a rhythm too slow to feel in the span of a life. And yet, perhaps what is most remarkable about these currents is not their fragility, but their persistence. For hundreds of thousands of years, through cycles of ice and warmth, the conveyor has carried on, never identical but always there, ferrying heat from one end of the planet to the other. Entropy pushes the world toward disorder, but the ocean resists, holding the pieces together, redistributing energy so that no place is left wholly isolated. A city may vanish, a language may die, but the water still moves, pulling the present into the future, pulling the past into the present, never fully stopping, never fully finished. If you listen closely, you might wonder, do we feel this heartbeat without knowing it? The monsoons that feed rice fields in Asia are linked to these currents. The rains that sustain forests in the Amazon are linked as well. Even the fog on your window, the snow on a quiet hillside, the mildness of coastal summers. All of these are rearrangements of heat delivered, delayed, or drawn away by the conveyor's slow, unseen hand. In that sense, every season we live through, every harvest, every breath of weather is somehow connected to a journey of water that began before we were born and will not end until long after we are gone. And if this is true, then we are never separate from the ocean's interior motion. We live inside its timeline, just as cells live inside veins, unconscious of the currents carrying them. To recognize this is to feel both small and strangely secure. Our world is steadied by a pulse it does not control. Still, there is unease here too. For what if the conveyor does change? What if, in some future, the heat shifts differently, the artery slows, the heartbeat fades? Could it be that civilizations themselves rise and fall not only with rivers and harvests, but with the submarine currents that tuck warmth beneath their shores? Could it be we are less architects than passengers, carried along a journey we cannot yet map? Perhaps that is why the metaphor of a heartbeat feels so right. It is not constant, not mechanical, not guaranteed. It is alive, irregular, prone to quiet stumbles, yet it gives life in every uneven beat. The ocean circulation is the slowest pulse we will never hear, but one we can always sense. And yet, if water can move like blood, carrying memory across centuries, then we must ask ourselves, what other hidden organs of the earth are still at work, silently keeping balance? What other systems, unseen beneath rock or air, are holding the story of life together, waiting for us to notice? What other systems, unseen beneath rock or air, are holding the story of life together, waiting for us to notice? One answer, quiet and crystalline, lies in the salt itself. For every drop of ocean water is not just liquid. It is a mixture, a distillation, a suspended record of evaporation, rainfall, melting, and freezing. Each grain of salt held in solution is a fragment of memory, a chemical trace that does not speak in words, but carries the hidden imprint of climate. Changes in salinity shape the weight of water, drive currents, and alter the flow of heat across the planet. But they also slip past us, invisible, tucked inside what seems like endless sameness. And yet, whenever we taste the sea, what enters our tongue is time itself. Salt is old, so old it may outlast stone. Crystallizes, dissolves, reforms, but never quite disappears. Locked in minerals, pressed within rock formations, found in the veins and deposits of ancient seabeds, now lifted into desert plateaus. Salt is the echo of vanished oceans. Each time sea ice forms at the poles, fresh water freezes first, pushing salt away, making the surrounding seas denser and heavier. These denser waters sink, and with them sink the stories of temperature, winds, and rains of that moment. Like an archivist filing new documents in an infinite library, the ocean arranges itself by salinity, stacking memories of climate not on shelves, but in layers of drifting water masses. To measure salinity, then, is to read, to glimpse what the earth has been whispering across epochs of storm and sun. What if every tiny shift in the salt content of the seas is the quiet testimony of global drama? A long drought, faintly salted seas, an age of floods, dilution and lightness, melting ice sheets, pouring fresh water into the mix, weakening currents like a slowing breath. Could it be that salt is more faithful than air, more patient than forests, more enduring than ice itself? Maybe, maybe not. Yet salinity has been there from the beginning, present in the primordial oceans, present in the tidal pools where life first flickered awake, and present today with the same quiet constancy. Like a signature, Earth keeps writing and rewriting. For scientists, the record is not metaphor but measurable. Cores of ancient sediments and the shells of tiny foraminifera preserve isotopic ratios that reveal both temperature and salt content of oceans long gone. These microscopic skeletons, layered like pages of a diary, hold clues to rainfall patterns tens of thousands of years in the past, to the rise and fall of ice sheets, to monsoons that fed civilizations and dust storms that buried them. Salinity, carried in calcium and oxygen isotopes, becomes a code through which forgotten climates are read. In that sense, the ocean is not just a place of motion, but of storage, where chemistry itself becomes the ink of planetary history. And still, salinity is not only about the past, it is shaping the present. In the Atlantic, fresh water runoff from melting glaciers in Greenland is lightening the surface waters, threatening to slow the great conveyor that ferries heat northward. Near the equator, evaporation intensifies, leaving saltier, denser waters behind. These contrasts are like tension points in the planetary body, subtle yet consequential, their balance determining how heat rearranges itself from year to year, century to century. And even as the numbers shift quietly beneath satellites and buoys, the ocean continues to breathe, too immense and too slow for us to grasp its meaning all at once. Perhaps the most humbling thought is this: salt does not forget. While rivers may change their beds, while mountains erode, while winds scatter the deserts, the salt remains. It revisits us when we sweat, when we cry, when we taste tears or the sea on our lips, as if the ocean has imprinted its chemistry upon our own biology, forever reminding us of where we came from. Not because salt is eternal, but because its movement is recurrence, its disappearance only temporary, its presence inevitable again and again, returning us to origin whether we ask or not. So when we look out over the sea, it is not only water we are seeing. It is a living archive of evaporated storms, of melted glaciers, of rainfall that fell not yesterday but in another age altogether. It is the hidden ledger of the Earth's memory, recorded in transparency and dissolved in visibility. Salinity is the handwriting at the bottom of the page, the faint script most of us never notice, but without which the story cannot be read. And yet, if salt itself is a memory, then what of the other traces the ocean has hidden away? What else, beyond chemistry, could be folded into its vast body, waiting in silence? Could it be that messages more physical, more solid than salt, still rest on the seafloor, remnants of forests, of mountains, of lives erased, preserved not in molecules but in stone? Could it be that messages more physical, more solid than salt, still rest on the seafloor, remnants of forests, of mountains, of lives erased, preserved not in molecules but in stone? If so, then perhaps some of those messages are not only in the ocean's depths, but also in the frozen realms above it, where ice and water meet in a slow, patient conversation. The ocean speaks to the ice, and the ice replies. Glaciers feed the seas, adding meltwater drop by drop, while seas, warmed by shifting currents, return the gesture by undoing the ice in sculpted silence. It is a dialogue that has lasted for millions of years, spoken not in words but in rhythms of melting and freezing, in rises and falls that extend across forgotten epochs. When we look at cliffs of ancient ice, layered like fragile books, we are in fact staring into these conversations. Each band of snow pressed into glacier carries tiny air bubbles, pockets of atmosphere sealed away like time capsules. Inside them linger isotopes, variations of oxygen and hydrogen, that point back to the temperatures and seas of ages before. The heavier isotopes tell of warmth, of water evaporated from oceans under a hotter sun. The lighter isotopes mark colder times, when immense glaciers grew fat and pulled the seas downward. To breathe across these old layers is to meet the breath of ancient oceans, suspended, unchanged, soft as memory resisting decay. And when scientists drill cores deep into polar ice, some stretching hundreds of thousands of years back, what they are really unearthing are the ocean's letters to the sky, preserved in frozen script. Glaciation reshapes the balance of the entire planet. When ice builds on land, water is pulled from the oceans, sea level drops, and coastlines stretch wider. When ice melts, seas rise, shorelines shrink, and the ocean reclaims what was once briefly given away. It is not only a cycle, but a negotiation. Pushing, pulling, adjusting, balancing. The ocean cannot be entirely itself without the ice, and the glaciers cannot exist without the ocean below. Each is dependent on the other, each both sculptor and canvas. Could it be that, more than currents, more than winds, the truest dialogue of climate has always existed between water solid and water liquid, between poles and sea? Maybe not. But to watch an iceberg crack softly into the sea is to witness both an ending and a beginning. One more line written into the ongoing exchange. There is a patience here that humbles. Ice sheets can grow for tens of thousands of years, only to unravel in a handful of centuries. Seas absorb the melted waters, but their response is delayed, spread across tides and deeper circulations that redistribute the weight across basins. The Antarctic ice sheet, vast and quiet, has collapsed and reformed many times. Greenland's ice, too, has surged, retreated, and pulsed like a slow breath. Between them, these polar mirrors have the power to redraw the boundaries of continents, to erase or restore coastal valleys, to drown planes or expose new land. And through all of it, the isotopic traces remain, marking each oscillation as faithfully as rings in a tree record the changing seasons. Some of the most profound forgotten histories of Earth are buried in these icy records. There was a time when the entire planet may have been wrapped in glaciers from pole to equator, a snowball Earth, when only the ocean currents flowing beneath the thick lid kept liquid water alive. There have been times when seas stood many meters higher than today, washing through lowlands where cities now stand. Every isotope layer, every trapped bubble whispers of these eras. The dialogue never stopped, only changed tempo, sometimes a whisper, sometimes a shout. Could it be that what we call climate is simply the ongoing conversation between frozen and liquid water, always negotiating where the boundaries of life will be drawn? Glaciers and oceans entwine in subtler ways. 2. Meltwater sinking into the North Atlantic freshens the seas, lightens them, and sometimes slowed the conveyor belt of currents that carries warmth poleward. A shift in ice can shift the pulse of the entire planet, altering wind belts, altering rain, altering deserts and forests oceans away. The dialogue becomes global without ever needing a voice. It is not a loud conversation. It moves like breath, slow and inevitable, too vast to hear in a single lifetime but unmistakable when viewed across time. Still, even as we measure, even as we read these records, mystery lingers. Entropy is always pulling time forward, wearing down even the sharpest signals, blurring the dialogue into background noise. Yet the patterns remain, not because they must, but because the Earth seems to have its own ways of engraving continuity into its body. Ice is one such record, ocean another. Together they keep the story alive against forgetting. Perhaps when you listen to the sea lapping against the coast, you are also hearing the melting of distant ice, traveling through currents to reach you days or months later. Perhaps when you see snowfall drift across a city street, you are also seeing vapor lifted from oceans far away, risen into clouds, remade into silence. The dialogue is not elsewhere. It carries through every small thing we experience, too vast to see all at once but undeniable when spread across the fabric of life. And yet, if this dialogue has lasted since before we can imagine, if ice and ocean have spoken to each other across entire epochs, what other voices might be part of Earth's conversation still? What might the rocks themselves, pressed with fossils and buried strata, be trying to say? Layered messages waiting in silence, speaking not with water but with stone. What might the rocks themselves, pressed with fossils and buried strata, be trying to say? Layered messages waiting in silence, speaking not with water but with stone. Perhaps before we can hear them, we must first linger with another presence in the ocean, something quieter than salt, subtler than currents, yet powerful enough to alter the fate of entire worlds. For the sea does not only carry the memory of water and ice, it also swallows heat. The surface, warmed by sunlight or by air that grows warmer above it, pushes that warmth downward. Some remains near the waves, shifting quickly with weather and season. But some, slowly and almost invisibly, is drawn deeper into the vast body, buried beneath layers of cooler water where it will not return for centuries. This is the sunken heat of the ocean, hidden but alive, waiting, never truly gone. Think of it as a kind of storage, a slowing of time itself. The laws of physics say that heat cannot vanish. It must go somewhere, it must be accounted for. And so the ocean becomes a vault, tucking away excess warmth in its interiors, keeping it from the air we breathe, from the rains that fall, from the surface we notice. We imagine climate as something measured in decades, yet here are cycles measured in centuries, heat forgotten by us though never forgotten by the water. What if the storms of tomorrow are already brewing in the warmth absorbed today, only to emerge long after we have gone? Could it be that the past we feel was decided not in the sky above us but in the deep, where stored energy waits, reshaping the future like a letter left unopened for generations? Oceanographers trace these movements with temperature readings, with drifting floats, with models that try to untangle the hidden motions of the abyss. They find that warmth sinks most often where surface waters grow heavy, at subduction zones where currents plunge toward the bottom like long rivers of heat. Once there, the warmth spreads slowly, creeping outward, diluting, mixing into the darkness. Some may not resurface for 1,000 years. A fraction, small, but significant, lingers until tectonic lifting or shifting pathways bring it back upward. An echo from another time rising quietly into the present. When it does, the atmosphere changes. Droughts appear, rains intensify, winds alter their course. To us, it seems sudden, but to the ocean it is only the release of memories it has been holding all along. There are times in Earth's past when this cycle has rewritten entire climates. Ancient warming pulses can be traced in sediment and isotope trails, signatures of heat stored then released. The abrupt end of glacial ages, when ice sheets collapsed not gradually but in bursts, has been tied to heat rising from the abyss into the surface. Not because the surface demanded it, but because the deep had been holding it too long. The balance tipped. Release became inevitable. Maybe this is the true tempo of climate. Not the gentle swing of seasons, not the span of a human life, but the slow emergence of sunken heat, invisible and patient, hidden until the moment comes to surface again. To picture this is to see the ocean as both guardian and trickster. It protects us in our brief time, hiding warmth from the sky, buffering the air we breathe from extremes. Without it, the planet would swing wildly, storms larger, droughts longer. But the protection is only temporary. What is hidden is not erased. What is swallowed will someday return. Could it be that even the ocean cannot refuse the law of entropy, that all stored energy insists on release, that nothing can remain buried forever? The ocean may delay, but it cannot cancel. It may withhold, but it does not forget. And so when you feel the breeze, or watch the tide touch the shore, you are also feeling centuries tangled together, warmth once absorbed and warmth still waiting, surface weather braided to deep memory. Perhaps the most extraordinary detail is that this heat, though invisible, touches us directly. Warming rainfall, shaping food harvests, steering migration, whispering through every storm. We are surrounded not only by the present but by oceans of the past, returning slowly, unavoidably, into now. And yet, if the sea itself can hold heat as memory, invisible and inevitable, then what else might endure within its hidden basins? What deeper archives, written not in warmth but in stone and fossil, might still be waiting for us, silent until we learn to listen? One answer is found not in temperature, but in breath, breath that has been captured, buried, and left to rest in the dark. For the ocean is not only the great carrier of water and heat, it is also the keeper of carbon, the hidden vault of the planet's respiration. With every passing age, carbon drifts downward, tied to the fragile lives of plankton and the shells of small creatures, slowly sequestered in the abyss. The deep sea is both lung and library, inhaling what we exhale, and writing it quietly into sediments where it will rest for centuries, millennia, even millions of years. Above, the ocean's surface teems with life. Microscopic plankton, delicate as glass and fleeting as mist, pull carbon dioxide from the air through photosynthesis. They live short lives, days or weeks at most, and when they die, their bodies rain downward in a gentle drift sometimes called marine snow. This endless snowfall of discarded shells, fragments, and carbon-rich dust sinks into the twilight zone, shaping a slow cascade that feeds the depths. The majority of it dissolves or is consumed by other drifting creatures, but some reaches the seafloor, pressed into sediments that layer one atop another, the way memories accumulate in quiet rooms where no one turns the pages. All the while, the atmosphere above is changed, moderated, softened by this transfer of breath into water. Some of this carbon is cycled back into the surface within decades, released as plankton are eaten or decomposed. But another fraction, the fraction that sinks deep enough, is removed from the atmosphere for centuries, effectively locked away by the weight of the ocean above it. In this way, the Earth breathes deeply and slowly. Carbon is drawn into the body of the ocean, stored where it cannot easily escape, and only returned when tectonic plates shift, when sediments are lifted into mountains, or when volcanism exhales the buried gases back into the sky. Could it be that the very air we breathe now once flowed through seas that no longer exist, held for millions of years and then offered back without ceremony. Maybe, maybe not. But the possibility alone is enough to change how we think of our relationship with breath itself. The balance here is delicate. Too little carbon in the air, and ice spreads endlessly, locking the planet in frozen silence. Too much, and warmth leaps upward. Seas rise, deserts expand. The ocean's carbon vault acts as a buffer, absorbing and releasing with a rhythm far beyond our own. Not because it chooses, not because it thinks, but because physics demands it, through solubility, through biology, through geology. It happens quietly, inevitably, like tides of breath rising and falling within the chest of the earth. And yet, deep in the abyssal plains, carbon takes on another role. The shells of organisms rich in calcium carbonate, like foraminifera and coccolithophores, pile onto the seabed. Over ages, they are compressed into limestone, chalk, or other sedimentary rock. Entire mountain ranges on land, such as the White Cliffs of Dover, began as these seafloor deposits. Oceans of plankton lives pressed into chalk and lifted upward by tectonic hands. Imagine, then, that every rock face we touch, every fossil discovered in ancient limestone, is part of a carbon story that began at sea, one that once drifted down in the snow of vanished plankton. It is a cycle so vast it makes us dizzy. From sky to sea to stone and back to sky again, looping endlessly, never quite lost. Entropy ensures nothing remains static. Even sediments, however buried, may someday return. Deep within subduction zones, old oceanic crust heavy with carbon-rich sediments is pulled into Earth's mantle. There, under heat and pressure, carbon is transformed but not destroyed, lingering until volcanic eruptions release it in gases, sending ancient breaths into new atmospheres. What vanished once as plankton may surface again through a volcanic plume centuries later. Is it possible, then, that the winds we feel today are infused with breaths caught first across oceans that predate humanity, exhaled not by trees or we ourselves, but by a planet working through its endless respiration? Perhaps this is why scientists call the ocean both a carbon sink and a carbon pump. It is as if the deep sea were holding its breath, then exhaling slowly, so slowly we cannot hear it. The balance has always been fragile and vast, always shaping whether forests thrive, whether rivers run full, whether ice grows or retreats. And though its timing feels abstract, beyond our perception, its consequences trace into every life, every quiet inhale we take without thought. If you could rest your ear against the ocean floor and listen, perhaps you would hear it. Not a voice, but a long inhalation, a holding, a patience we cannot match. Carbon stored away, waiting to rise again, waiting to take shape in air, in trees, in us. We are composed of borrowed breath, drawn from carbon that might once have been a drifting plankton, a seafloor stone, or a molecule hidden in abyssal dark for 10,000 years. The library of the ocean does not simply preserve, it lends. It writes us into its story whether we notice or not. And yet, if the sea can hold not only heat but also the most essential element of life, if it can write breath into stone for ages untold, what then of the fossils themselves, the imprints of lives once lived? What stories rest there, pressed into layers of rock, waiting quietly for us to uncover their memory of worlds long extinguished? When we turn our gaze downward, we come to realize that the ocean floor is not only an archive, but also a graveyard. It is layered with the shadows of the species that came before us, a quiet record of extinction and survival. Each thin band of sediment holds whispers of collapse. Each buried grain of ash, each fragment of shell, is less a relic and more a tombstone inscribed upon the drifting seafloor. The ocean is, in this sense, a cemetery of forgotten climates. With every great environmental shift, with every pulse of warmth or glacial cold, with every surge of volcanism and every chemical imbalance, species perished, and their remains joined the slow rain of marine snow that drifts endlessly downward. This accumulation is patient, almost hypnotic, so delicate it might seem invisible, yet powerful enough to build whole geological records. To us, the seafloor appears still, endless, blank. But in reality, it is stacked with the traces of lives long lost. Its layers are chronicles of silence, pressed flat under the weight of new ages arriving above. If you were to lift a core of sediment, just a narrow cylinder bored into the abyssal plain, you would find stripes of history painted into it. Certain layers show a sudden darkening, as if ink spilled across the pages. These are the black shales, rich in organic matter from blooms of plankton that died off en masse when waters filled with too much carbon and oxygen was stripped away. In other places, there is a stark boundary, like a line drawn by fire. A thin band of rare elements, like iridium, marks the fall of an asteroid 66 million years ago, and with it the extinction of the great reptiles, the dinosaurs whose shadows never returned. That impact is remembered here not through fossils of bones, but through fine ash and altered chemistry sealed in the sea's floor. The waves themselves were their pallbearers, laying their final trace gently into burial. Could it be that the ocean floor knows these endings more fully than land ever could? Land is eroded, mountains crumble, rivers wash fragments away, but the abyssal plains, miles deep under quiet water, accumulate layer after layer with almost infinite patience. They receive everything. The dust of deserts carried by wind, the pollen of forests that no longer exist, the microscopic shells of plankton that lived in numbers beyond imagining. Once these reach the bottom, they are rarely disturbed. It is here that entire eras are written, not in monuments of stone, but in quiet sediment, where loss is preserved without judgment. Extinction, in this way, becomes part of the ocean's memory. The Permian extinction, the greatest collapse life ever endured, when 90% of marine life vanished, remains etched in ocean sediments as abrupt chemical changes, carbon spikes, indicators of suffocation. The smaller, quieter extinctions, too, the turnover of species with shifting currents, the slow disappearance of corals during warming intervals, the fading of creatures we rarely imagine, are all recorded here. Maybe nothing is ever truly forgotten. Maybe the ocean keeps a more faithful register than we do, not because it intends to, but because entropy itself, which erases memory from the living, inscribes it into matter as it decays. And yet, within these tombs, there is a strange kind of rebirth. After each collapse, new species rise, new forms adapt, new ecosystems take the place of those that fell. The sediments show this, too. Where one layer carries the markers of sudden loss, the bands above slowly thicken with new shells, new chemistries, new balances. The ocean, then, is not simply a place of endings. It is both a grave and a cradle, an eraser and a palette. Every extinction clears a space, and life, patient, experimental, fills it again. Is it possible that this cycle, this pattern of erasure and resurgence, is the very rhythm of evolution itself? Maybe, maybe not, but it calls us to think of endings differently, not purely as silence, but as transitions folded into the ever-turning wheel of time. And we, too, leave our record here whether we mean to or not. Fossil fuel burnings, aerosols, plastics, discarded bodies of industry. All of these are sifting downward even now, entering layers that millions of years from now will tell of us. A future intelligence could drill cores and find our fingerprints, our accidents, our collapses. They may not know our stories, but they will know something ended, and something began again afterward. They will know us in the way we now know the vanished ammonites, the trilobites, the giant marine lizards. Not as lives, but as traces, as ghosts sealed in geology. Perhaps that is the humbling truth that sleeps beneath the ocean's surface. That extinction is less a singular event than a constant layering, a slow accretion of voices fading into sediment. Each line in the mud is an ending. Each line is a beginning. The ocean does not interrupt, it does not rush. It listens, and it continues to keep the tally. And yet, if the ocean floor can preserve the ghosts of worlds long gone, if it can archive every loss in its endless silt, then what about the worlds beneath that floor itself? What mysteries might lie in the buried crust, in the rocks sinking into subduction zones, rewritten not in layers but in molten memory deep within the earth? Before we journey there, we might pause with something more familiar yet just as profound, something that touches our shores each day: the tides. To us they seem simple, waves retreating, waves returning, but beneath their rhythm is a system far older, far stranger, one that thinks not in hours but in centuries. The tides are pulled into being by the moon's gravity, by the slight tilt of Earth's axis, by the subtle tug of the sun, and they are sculpted around the contours of continents and the shifting floors of the sea. They are not mechanical, not exact, but alive in their irregularity. Each tide we witness on a shore has traveled across entire oceans, shaped as much by the deep basins it flows across as by the pull of the heavens. We often think of them as fleeting, rising now, gone in a few hours, but in truth each tide carries with it the resonance of countless ones before and countless ones to come. When tides move water, they do more than shift coastlines. They stir nutrients from the deep, lifting the remains of sunken plankton into the light, where new life can flourish. They blend warm and cold, surface and depth, creating invisible welds that ensure ecosystems remain connected. Without tides, many of the richest environments, the estuaries, the deltas, the coastal shallows bursting with life, might never have been nourished with such constancy. And because of this, tides rearrange the atmosphere itself. Through the microscopic lives they feed, they help determine how much oxygen fills the sky, how much carbon is swallowed by the seas, how much balance remains between air and water. Could it be that the soft pull of the moon has shaped not only the seas, but the very breath of every creature walking on land? Maybe, maybe not. But imagine how deeply our lungs are tied to these unseen rhythms. Tides stretch far beyond the daily rise and fall we notice at a shore. There are grander, longer cycles too, lunar nodal cycles swinging over 18.5 years, shifting where tides are strongest, long-term resonances where the geometry of basins redirects entire flows. Over centuries, these changes adjust erosion and deposition, feeding or withdrawing wetlands, remaking habitats slowly but relentlessly. On still longer timescales, the drift of continents reshapes where the tides concentrate. In the age of Pangaea, tides were shallow ripples, muted across global shores. As the continents spread, basins opened that amplified them 100-fold. We think of continents as shaping mountains, as drawing borders, but they also sculpt the heartbeat of tides, dictating how they move, where they focus, how strongly they can breathe through the centuries. What if memory itself is carried in tides? They do not record with ink or isotope, but with motion. Each tide carries forward the echo of the last, tugged by the same moon that circled above ancient oceans, tugged in the same slow cadence. The waters are not identical, drops lost and replaced, heat moved and remixed. But the rhythm persists, a repetition that has endured for billions of years. This is not a clock we can hear, yet we feel it unconsciously, in the ebb and flow of coasts, in the ways fishing seasons arrive, in the mudflats revealed and swallowed repeatedly as if time itself were pausing and unpausing. Perhaps when whales follow migrations, when birds time their crossings, when corals release their spawn in synchrony with the lunar cycle, they are listening in ways we no longer know how. The tide calls, and they respond not just because of water, but because of the memory of cycles older than their species, older than ours. To watch a tide is to feel humility, for it shows us a rhythm beyond ownership. We cannot rush it, cannot slow it, cannot silence it. It has been moving long before language, and it will move long after we are gone. And yet, tides are not indifferent. They exchange energy with Earth itself, pulling faintly at the planet's rotation, lengthening our days by fractions of seconds across geological epochs. Minute by minute, tide by tide, the very length of time as we know it has been stretched by the dialogue of ocean and moon. Could it be that time itself, our measurement of it, our experience of it, is subtly shaped by the tides, by this constant gentle tug across centuries? And yet, if tides carry memory not only in hourly patterns but across centuries, if they bind the sky to the sea and the sea to the air, then perhaps we must finally wonder, what of the rocks shifting below it all? What of the continents themselves, carried on drifting plates, subducting, remaking worlds, holding secrets far deeper than tides could ever reach? For at the edges of oceans, in the shadowed trenches where the seafloor bends down into darkness, another process unfolds, slow, relentless, and difficult even to imagine. It is called subduction, and it is here that the ocean writes its final chapters into the planet, only to have them rewritten again. At a glance, the deep-sea trenches are scars, jagged seams where plates collide, but in truth they are more than that. They are gateways inward. The ocean floor, which for millions of years has accumulated memory, fossils, dust, shells, carbon, sediments, is slowly dragged beneath continents, folded back into Earth's mantle. It is not loss in the way we might think. It is a swallowing of memory, a storage beyond our reach, where time works in temperatures and pressures unthinkable. Water descends too, carried within the very minerals of the crust, setting off reactions that melt rock and change its nature forever. The ocean is taken back, absorbed, never gone, only waiting to return in forms we cannot yet see. To follow a segment of ocean crust into the deep is to follow a world into forgetting. Fossilized shells that once floated in shallow waters are drawn downward, erased from ordinary history by the crushing silence of Earth's mantle. Carbon, once light as breath or lace-thin skeletons, becomes trapped, locked into rock, transformed by pressures that crush all shape but preserve essence. Geological isotopes, tiny chemical signatures left by oceans long gone, survive here too, markers carried deeper and deeper into the unseen body of the planet. Could it be that the deep mantle holds traces of oceans that no longer exist at all? Maybe, maybe not. But it is almost certain that, far below our feet, remnants of seas and skies dissolved millions of years ago are still being kept, hidden from our notice, alive in forms unrecognizable. And then, in time, the mantle releases what it holds. Subduction does not only bury, it fuels rebirth. Water descending with the crust lowers the melting point of mantle rock, sparking volcanism, igniting arcs of fire along continental margins. There, in cascades of ash and rivers of basalt, the ocean rises again in altered breath. The carbon drawn into the depths returns as volcanic gases. The lost water steams upward, released after millennia of burial. The memory returns, but changed, transformed by fire, rewritten in molten language. Volcanoes are not just expressions of Earth's core. They are also the voices of oceans that sank into the body of the planet, now exhaling back into the sky. Every eruption, then, might be seen as a story resurfacing. Every puff of volcanic gas, every column of ash, is the final chapter of a cycle that began long before us, when storms eroded mountains, when rivers carried minerals to the sea, when shells collapsed onto abyssal plains. Subduction swallowed them, but not to erase, only to alter, only to bide its time until the mantle spoke them into being again. Is it possible that what we call atmosphere today, the air we rely upon, is in part the exhalation of oceans buried and returned billions of years ago? Not an atmosphere made new, but one made again, and again in endless cycles of inhalation and release. There is something humbling in this thought. For while we see the surface ocean as a keeper of memory, it is only half of the story. The rest of its record disappears into trenches so deep we can scarcely explore them, places where the planet seems intent on folding itself inward. Yet what is carried there does not vanish. It is part of a planetary metabolism, a recycling through which oceans breathe just as much as atmospheres do. Not because memory resists decay, but because even decay here becomes transformation. What is forgotten at the surface is rewritten below. What is erased in one form always reappears in another. If the ocean is a library of breath and fossils and climates, then subduction zones are the bindery. They take what has been written, tear it down into raw material, and press it into new scripts, new geologies, new futures where mountains rise and continents shift. And though the human eye will never see most of this process, the evidence is everywhere around us. The limestone ridges that top mountaintops far from any sea, the volcanic arcs that glow with subterranean fire, the chemistry of magma, carrying signals of once buried plankton, once dissolved water, once fallen rain, now reshaping landscapes anew. To lie awake at night and think of subduction is to imagine the earth as a being that never rests, consuming and remaking, inhaling oceans and exhaling continents. Entropy shapes it, yes, yet within entropy lies creation, a cycle not of permanence but of endless transition. Perhaps this is what the planet has always been. The art of keeping nothing still, of letting memory fade only so that it can surface in a different form, carrying echoes too deep to ever be fully erased. And yet, if ocean memory can be swallowed and remade as fire, leaving only fragments for us to find, what might this say about the fragments of our own story? Could it be that, like the fossils and waters drawn below, everything we are will someday exist only as layers transformed, silent, compressed, stored, not gone, but waiting for some unimaginable rebirth? To follow that thought is to find ourselves pulled toward another secret hidden within the sea. For the ocean is not only a surface of waves or a floor of archives. Between those two, in its living body, there are rivers, not the kind drawn on maps, not the ones we walk along or cross with bridges. These are rivers of density and temperature, of salt and heat, flowing invisibly, deeply, inside the ocean itself. We often think of rivers as belonging only to the land, carrying fresh water from mountainsides into the waiting arms of the sea. But what if we thought of the sea itself as threaded with rivers, each one driven not by gravity alone, but by contrasts in salinity and warmth, by the subtle balance of weight in every cubic meter of water? These are the thermohaline currents, rivers hidden beneath the surface, branching wide like arteries, weaving continents together without our notice. A single flow may be thousands of kilometers long, a quiet transport that moves more water in a day than the greatest land river could ever move in a century. To drift with one of these hidden rivers would be to experience time as few can imagine. Imagine sinking into the North Atlantic near Greenland, where surface waters grow cold and dense enough to dive downward. Once descending, you would join a current that travels the length of the Atlantic, brushes the southern tip of Africa, enters the Indian Ocean, and eventually disperses into the Pacific. Centuries may pass before your molecules rise again to meet air. To us, it is unimaginable. A journey longer than recorded history, threaded silently into the ocean's patient bloodstream. Maybe not, but perhaps this is how Earth breathes across epochs, through circulations that rearrange what seems fixed, transporting warmth, salt, carbon, and memory from one end of the planet to the other. What if we see these currents not only as pathways of water but as messengers of climate? Warmth carried northward softens winters in Europe, while cold, deep return flows stabilize the rhythm of monsoons half a world away. Inland weather, even on farms, deserts, grasslands, rests upon the positions and strength of rivers that no one can see, moving in darkness thousands of meters below the surface. Could it be that civilizations have risen and fallen with the pulse of these unseen streams, living at the mercy of a motion they never sensed but always depended upon? Unlike surface rivers, which carve valleys and change their courses quickly, these inner rivers work with extraordinary patience. They shift slowly, sometimes staggering, sometimes strengthening, sometimes faltering into silence for reasons still debated. In epochs past, there were times when the conveyor nearly halted, when meltwater freshened the seas and lightened them until density no longer pulled water downward. The result was dramatic. Sudden chills across continents, droughts where rains had once nourished forests, abundance vanishing in a matter of decades. Yet the rivers always returned, not in the same forms, not in the same strengths, but flowing again as if memory itself lived in their persistence. The sediments on the seafloor hold isotopic evidence of these hidden changes, ratios of oxygen and carbon marking which waters sank, which rose, which pathways remained open, which faltered. Like ghosts traced in chemistry, the rivers reveal themselves not directly, but in the imprints they leave in fossils, in layers of mud carried quietly from land, in isotope trails preserved for us to read. Not because they wish to be known, but because nothing in this world can move without leaving some mark behind. Perhaps the most haunting thought of all is that these currents, as immense as they are, may also be fragile. Small shifts in temperature, small surges of fresh water from melting ice, could slow them, alter them, even silence them again. And yet, even if they do falter, they are never truly gone. They are part of Earth's way of redistributing what would otherwise be imbalance, ensuring energy and salt are never kept in one place for long. Every stream that vanishes returns eventually, remade in another form, following the rules of physics but appearing to us as the patient rhythm of something alive. And so, when we stand by a river on land, watching it slip past into the sea, we may forget that the ocean carries rivers of its own, invisible yet more enduring, currents that have tied past to present and present to future. They are not lines we map easily, yet we live within them every day, in the warmth of a season, in the rains that return, in the possibility of life itself. And yet, if these hidden rivers move unseen inside the ocean, if they tie together the fate of continents and the shape of climates, then what of the rivers embedded even deeper, below the ocean crust, streams not of water but of molten stone? What hidden flows beneath our feet might be carrying memory into the heart of the earth? To follow that question brings us to a different kind of archive, one that is even more delicate, more fragile, and yet astonishingly durable. For if the ocean has rivers within it, it also has echoes. Echoes not heard by the ear but measured in the smallest details of matter itself. These echoes are carried in isotopes, written invisibly into shells, corals, and the ancient skeletons of organisms so small we can barely see them. Together, they form the ocean's most intricate diary, a record of temperature and oxygen, of balance and imbalance, written not in ink but in chemistry. Each time a tiny organism, like a foraminifera, builds its shell from calcium carbonate, it draws upon the ocean water around it. In doing so, it unwittingly incorporates a ratio of oxygen isotopes, slight differences in the atomic weight of the same element. The delicate balance between the heavier oxygen-18 and the lighter oxygen-16 is shaped by temperature, by rainfall, by the expansion and retreat of ice sheets. In warm periods, evaporation leaves behind water enriched in the heavier isotope. In colder times, the lighter isotope is locked into snow and glaciers, leaving the ocean fractionally altered. To the eye, all water looks the same, but at the atomic level, these tiny shifts are signatures, like faint fingerprints pressed into glass, enduring long after the hand is gone. Corals tell the story too, each growth band like a tree ring locking in oxygen isotope ratios that whisper of ancient seas. There are bands of warmth, of long summers, of times when rainfall swelled or waned. Over lifetimes of centuries, coral reefs record not only the pulse of seasons but of entire ages of climate. Seashells, too, preserved in shore sediments, are another form of script. From them we have begun piecing together tales of monsoons stronger or weaker than today, of droughts that lasted lifetimes, of oceans that swung wildly from heat to cold and back again. Could it be, then, that every creature unknowingly writes upon the pages of time, carrying in its body a memory the earth itself has handed to it? Maybe, maybe not. But the chemistry tells us that, without intending to, life is always recording. The most haunting examples come from ocean cores. Scientists sink long cylinders into the seafloor and pull up layered histories. Within those layers are the skeletons of foraminifera, their shells intact even after hundreds of thousands of years. By measuring isotopes within those shells, scientists reconstruct paleoclimates, the heat of ancient summers, the cold of glacial maximums. From them we know that ice sheets once reached far deeper into continents, that oceans once rose higher than today's, that carbon has cycled in great oscillations. The data unfolds like scenes from a silent film, revealed just enough for us to glimpse epochs we never saw. Each isotope ratio is a word in a language we have only recently begun to read. And yet these echoes are not confined to faraway pasts. They shape our perception of the immediate present. Isotopes in rainfall reveal the sources of storms. Isotopes of carbon in the atmosphere reveal the fingerprints of fossil fuel burning, a new and accelerated entry in Earth's diary. In lakes, ice, caves, even in our own bones, isotope ratios whisper of where the water has been, which winds carried it, which climates shaped it. It is almost unsettling to realize we are participants in this writing. We, too, are inscribed with the chemical echoes of the age we inhabit. Our teeth hold the isotope signals of the waters we drank as children. Our very hair carries evidence of latitude, rainfall, diet. We are records walking, written as much as we are living. Perhaps this is where the hypnotic power of isotopes truly lies, in their dual role as both memory and mystery. On one hand, they anchor us with clarity, decoding the climates of tens of millions of years past. On the other, they remind us how fragile perception is, how much can change while leaving so faint a trace. What if memory everywhere is like isotopes, invisible but enduring, faint yet undeniable, not permanent in form, but persistent in ratio, durable in pattern? Could it be that memory itself, whether of oceans or of us, is less about detail and more about proportion, about the balance of what remains when much has dissolved away? Entropy, the slow eraser, ensures that most of what happens will fade. Species vanish. Languages disappear. Epochs collapse into dust. And yet isotopes remain, still carrying faint structural echoes, drifting across deep time like musical notes sustained longer than we thought possible. If silence is the natural end, then isotopes are the whispers within silence, proof that even silence is never fully empty. And so when we hold a shell in our hand, when we look at thin limestone or delicate coral, we are really holding the trace of oceans as they were thousands of years ago, breaths of climates long expired, preserved not in story but in ratio. An isotope cannot lie, it can only be, and by simply being, it carries time forward, delivering memory across extinction, across change, across forgetfulness. And yet, if isotopes can carry the diary of oceans, if they can write into the smallest details the memory of worlds gone, then what might the rocks themselves be keeping? Beyond shells and corals, in the depths of mountain stone and buried strata, what larger inscriptions lie waiting, pressed in fossils and scarred in minerals, speaking in languages even older than isotopes themselves? To search for those records brings us back to a truth both fiery and hidden. The ocean is not only a keeper of water, salt, and memory, it is also a mirror of fire. Beneath its surface, in places where light never reaches, whole landscapes of volcanism are alive. Here, lava spills unseen. Heat radiates upward. Minerals bleed from the crust into the deep. It is as if Earth's inner fire has found a way to breathe quietly beneath the still veil of the sea. Most volcanic eruptions happen not on land, but beneath the waves. Along mid-ocean ridges and fracture zones, molten rock wells upward, creating new crust and spreading continents apart. When magma erupts here, it does not explode into billowing clouds but meets water with silence, forming pillow lavas that harden in glassy shapes, evidence of fire cooled instantly by the weight of the sea. These eruptions release heat into currents that then rise and stir, altering circulation in ways we cannot always measure. Not dramatically, not in a way most lives would notice instantly, but in subtle accumulations, shifts that affect climate far above. Could it be that even the weather we experience on land is in part the echo of unseen eruptions beneath the sea? Maybe, maybe not. But the possibility lingers, as deep and quiet as the eruptions themselves. From the hidden vents along mid-ocean ridges flow more than heat, there flows chemistry. Superheated water erupts from the crust, blackened with minerals, rich with metals like iron and manganese, pouring into cold seawater and falling like smoke. These are the hydrothermal vents, the black smokers and white smokers, chimneys built by minerals accreting in minutes, growing taller than we do, crumbling and rebuilding continuously. What they release becomes dissolved into the ocean body, nutrients carried away by deep currents, feeding ecosystems unlike any other. Around them, life thrives without sunlight, feeding not on photosynthesis but on chemosynthesis, bacteria transforming chemicals into energy. Here, fire gives birth to life through water, reshaping not only the ocean's chemistry but its biology. And yet, this chemistry circles outward. The iron released by hydrothermal vents drifts into the ocean body, where it fertilizes the growth of phytoplankton, those microscopic plants that form the base of ocean food webs and produce much of Earth's oxygen. A volcanic eruption beneath the sea may therefore shape the air we breathe months or centuries later, quietly, invisibly, but profoundly. Fire hidden in water reshapes the sky, not with the spectacle of flames but with atoms rearranged, whispered into molecules that will drift across continents. The sea is not only a receiver of memory but an alchemist, taking fire into water and turning it into air. Geologists trace records of these underwater fires in the isotope trails of sulfur and carbon. They mark shifts in atmospheric composition stretching back to forgotten epochs. Some catastrophic events, mass extinctions preserved in seafloor sediments, bear the scars of volcanic pulses so vast they rewrote the chemistry of oceans and atmosphere alike. Basalt floods, mid-ocean eruptions, underwater arcs of magma. All of them acted through fire hidden in the sea, altering currents, climates, even the possibility of life itself as it would continue forward. There is a strange humility in realizing how much of Earth's history has been dictated by things no one could see. We measure the surface air. We track the surface seas. But below that surface, volcanic reshaping continues endlessly. Old crust pulled down in subduction zones melts, rises, returns as magma, and erupts again. A cycle of descent and ascension written not in myth but in geology, its evidence scattered across the depths. Entropy ensures rocks will break down, will spread, will be remade. Nothing stays untouched, not even the ocean floor. And what of memory here? The lavas themselves carry memories in their chemistry, ratios of isotopes, the concentrations of gases trapped in crystals, markers of how hot the mantle was, how much carbon and water it released. If we learn to read them, we glimpse not only the fire of now but of ancient pasts. Every pillow lava on the mid-ocean ridges is a page. Every mineral chimney is a sentence rising into water. Every gas bubble is a lingering consonant of Earth's interior voice. Perhaps to call the ocean a mirror of fire is to remember that opposites are never fully separate. Water and fire, silence and eruption, stillness and violence. These are not binaries but partners, each shaping the other across unfathomable spans of time. The ocean hosts fire, contains it, dilutes it into chemistry, distributes its heat into air. Fire, in return, feeds the ocean with minerals, creates new crust, reforms the very basin in which water gathers. One does not undo the other. They are dialogue more than contradiction, an interior conversation about balance and renewal. And yet, if fire sleeps so restlessly within water, if it can alter sky and sea alike from below, then what of the sky itself? What hidden memory lies not in Earth's interior, but above us? In the atmosphere that has thickened, thinned, shifted, and breathed through forgotten ages, carrying its own diary of loss and renewal. To look into that record is to remember that the ocean and air are never truly separate. What the water moves, the air reflects, and there have been times, rare and unsettling, when the ocean's inner rhythm, the great conveyor of currents that pulses like a planetary heartbeat, has slowed, even stalled. These are the stutters in Earth's respiration, the pauses that reverberated across continents and ages alike. The conveyor, driven by salt and temperature, links the equator to the poles in a loop of circulation. Warm water carried north, cold and heavy water sinking south. It turns the whole of the ocean into a single continuous flow, a current that thinks in centuries, in millennia. But paleoclimate clues show us that this flow is not guaranteed. Ice sheets melt, fresh water spreads, salinity lightens. At certain thresholds, the heavy northern waters no longer sink, and the loop weakens. Sometimes it falters for centuries, sometimes for millennia. The signs lie preserved in deep-sea cores, in isotopes nestled within delicate shells that quietly recorded changes in oxygen balance, revealing abrupt, disorienting shifts. When the ocean stalled, the world above shifted with it. Europe fell into sudden freezes, while other regions swung into searing drought. Monsoons weakened or collapsed. Rain belts drifted or vanished entirely. All of this emerged not in slow arcs, but in relatively sudden jolts. Decades at most, lifetimes for those who lived through them, though they only sensed weather and hunger, not currents shifting silently beneath them. Could it be that entire epochs of human struggle, even the fall of civilizations, have ridden not only the rise of rivers and the sweep of storms, but this deeper, invisible rhythm? Maybe not. And yet the evidence glows within the mud of ancient seabeds, telling us that climates humans once relied on were tugged sharply this way, and that by oceans choking upon their own flow. In Greenland's layered ice, bubbles of air hold the mark of these pauses. Traces of methane, carbon dioxide, small isotopic shifts indicate how dramatically the atmosphere itself was rearranged by a stalled conveyor. Whole forests may have withered under dry skies. Crops, barley, wheat, may have been abandoned as rainfall vanished. Dust marks the presence of famine, eroded soils tumbling into rivers as lands cracked. Human history is fragile, balanced upon delicate climate, and the conveyor appears again and again as one of the silent mechanisms upon which fate turned. Yet memory here is elusive, for while we see sharp transitions marked in isotopes and dust, cultures leave fewer details behind. Collapsed field, a city dwindling, a migration whose cause is half remembered. Perhaps humanity has always been just slightly aware, sensing something unsteady in the balance of rain and harvest, but never knowing that the cause lay not in the heavens, nor in the wrath of gods, but in an ocean pause far away, a stutter in the circulation hidden deep below. The ocean does not stall forever. Given time, it recovers. Density recalibrates. Fresh water slows its flow. New equilibriums emerge. Warmth accumulates and reorganizes. Gradually, the conveyor returns, not identical but reborn. But in the interval of its faltering, lives change. Ecosystems collapse. Patterns reset. And the scars of these adjustments ripple forward into new climates, leaving behind forgotten whispers of civilizations undone. Entropy speaks here too, not as destruction but as rearrangement, memory written through damage and rediscovery. There is something profoundly humbling in seeing how much depends on something so easily invisible. We step outside and feel air on our cheeks, moist, dry, warm, chilled. Yet hidden currents beneath the surface ocean may have scripted that sensation years, even centuries before. Glasses of water, handfuls of grain, the security of homes. All may have been shadows cast by a circulation that once slowed, paused, or failed. And so every time we peer into the ocean's record, its isotopes, its sediments, its pauses, we are quietly reminded of this entanglement, that life on land and life at sea are braided together, not through storms alone but through the hidden arteries of heat and salt. Perhaps what unsettles most is not that the ocean once stalled, but that it is capable of stalling again. If the past breathes through isotopes and shells, then the question emerges softly, without resolution. And yet, if the sea's heartbeat can falter so profoundly, reshaping continents in silence, how many other stumbles might Earth still hold in its hidden rhythms? Moments of pause vast enough to unmake the world we think we know. To lean into that thought is to enter the territory of entropy, the law that governs all systems, the tendency of order to slip toward disorder, of patterns to decay, no matter how mighty they may seem. The ocean, too, is not exempt. It resists, it delays, it rearranges imbalance into cycles of motion, but over eons it cannot escape. Eventually, entropy reaches even the largest of circulations, reshaping the hidden symmetry of salt and current into something else, scattering balance and creating new climates from disorder. To look at the ocean today is to see a system in equilibrium, but equilibrium is temporary, a fragile stillness stretched across immense scales. Waters rise with heat, sink with cold, carry oxygen, carbon, nutrients. They form spirals, gyres, overturning loops connecting poles and tropics. For now, the system resists decay by redistributing energy, smoothing extremes, weaving warmth into regions that would otherwise freeze, carrying cold into places that would otherwise overheat. But entropy lies in wait, urging every organized motion toward unraveling. The conveyor one day weakens. The stratification tightens. Exchanges slow. What was once orderly circulation decomposes into something stranger. Not gone but rearranged into a form less predictable. Maybe not in years. Maybe not in centuries, but in deep time, certainly. The sediments remember these dissolutions. Layers of ocean mud tell the story of circulation patterns that collapsed, climates that rushed into drought or snow without warning. Some isotopic bands reveal centuries of stagnation when deep waters ceased to oxygenate, when life in abyssal plains suffocated and vanished into silence. Other records speak of pulse-like surges, sudden reorganizations where new river paths of current emerged almost overnight. Entropy does not erase, it transforms. Disorder itself becomes the seed of a rebalanced system. Could it be that every collapse of ocean circulation is less an ending than a reminder that permanence was never part of the design? There is beauty hidden even in this inevitability. For from disorder comes newness. When entropy unravels one set of rhythms, another emerges, carrying its own balances, unfamiliar but functional. Cooler ages alternate with warmer ones. Wet epochs succeed dry spans. Entire ecosystems emerge that could never have lived in the prior order. In this way, entropy gives renewal as much as it takes away. Perhaps the ocean's greatest strength is not its resistance to change but its ability to let go, to reshape itself endlessly against the pull of disorder. Not because it wills it, not because it selects it, but because the laws of decay are also the laws of adaptation. Life follows in this wake. Tiny organisms, plankton and foraminifera, adjust to altered chemistries and inscribe the new climate into their shells. Coral reefs bleach, die, regrow in different forms. Species vanish, replaced over millennia by others forged under fresh conditions. Extinctions are written in these thresholds, but so are emergences. The great oscillations of oxygen and carbon, of acids and bases, of heat and cold, all find their anchor in entropy's slow pull on the ocean's ability to circulate, to refresh, to balance. It is strange to think that even currents, which feel eternal to us, are in fact fragile arrangements of density and salt, bound only temporarily before diffusion blurs their edges. Over eons, entropy ensures deep and shallow layers will grow apart, will stratify, eliminating the mixing that gives life its continuity. Oceans may one day slow into vast, stagnant basins, thick, unmoving, collecting carbon without release. Or they may reorganize into systems unlike anything we know today, with flows and patterns so different that climates will redraw themselves entirely across land. Is it possible that the world we inhabit, the one we consider normal, is only a brief interlude of ordered circulation between longer spans of disorder and renewal? Maybe, maybe not. Even in its decay, though, the ocean writes memory. Isotope trails remain in the chemistry of waters transitioning from organized to chaotic. Fossil layers record the pulse and silence of circulation long after it has changed. Entropy ensures no arrangement holds, but it never erases the trace of what was. Every scattered pattern becomes the foundation upon which the next order builds. In that sense, entropy does not only dissolve the ocean's motion, it inspires its capacity to begin again. And so, to think of the ocean as immune to entropy is comforting but untrue. Its gyres decay, return, decay again. Its deep currents falter, stall, then give rise to new flows. Its ability to resist disorder exists only in the short term, while across deep time it succumbs, not in failure but in transformation. Like stone worn into sand, like memory stretched into silence, the ordered becomes the unordered, and from that, forms reassemble. Perhaps what makes this most haunting is our own sense of permanence, our belief that climates must remain as they are because we have known them only briefly. But from the perspective of entropy, this is an illusion. Oceans do not promise stability, only improvisation across epochs, only the endless handing forward of balance into imbalance and back again. And yet, if entropy always draws the ocean towards scattering, towards silence, what other memories of Earth might be scattering too? Perhaps not only water, but air, stone, even ourselves, dissolving slowly, written once, erased, and then written again? To lean deeper into that thought is to arrive in the slowest rhythms the planet has ever kept. For the Earth has been sculpted not only by volcanoes and tides, not only by rivers and winds, but by the vast breath of glaciation. The great ice ages did not arrive suddenly, and they did not retreat without leaving their signature. They were guided and timed, at least in part, by the way the ocean chose to store and release its heat. Ice speaks in silence, but the silence was prepared for it by the motion of the sea. Glacial cycles are often imagined as the domain of the poles, written only in white landscapes. Yet their heart is entwined with the deep ocean, where waters colder than death itself gathered heat and carried it like secrets across millennia. In times when Earth tilted just slightly differently toward the sun, orbital patterns shifted the balance of light on continents and seas. Small changes by themselves, fragile and almost imperceptible. But when the ocean translated those changes into stored heat, when it withdrew warmth downward into circulation loops, ice sheets swelled and advanced. When it released that warmth back upward, Suddenly and almost violently, ice sheets crumbled and seas rose. It was not the sky alone that carved glacial ages. It was the water below the sky, stockpiling hidden energy and deciding in silence when to let it out. We can glimpse this in isotope ratios drawn from cores of ice and sediment, aligned like parallel diaries written in two hands. The ice cores tell of atmospheric carbon, of snowfall, of temperatures preserved in trapped bubbles. The ocean cores, meanwhile, tell of currents shifting, of oxygen content rising or falling, of carbon stored deep in abyssal plains. When the two are paired side by side, we see the rhythm. Oceans sinking heat and carbon in long intervals, locking Earth into extended cold, then exhaling them back in abrupt releases that warmed forests, unlocked rivers, and drew life out of glacial grip. Could it be that the trigger for thaw was never the heavens, but the sea remembering what it had hidden? Maybe, maybe not. But the timing of warmth always follows the whisper of deep waters returning their stored energy. On the surface of continents, this dialogue shaped the fate of ecosystems and civilizations yet unborn. Entire valleys in Europe, now green and supple, were once stripped bare ice sheets stretching for hundreds of kilometers, their silence absolute. Mammoths and great beasts roamed plains that existed only because seas carried warmth into storage, lowering levels, pulling water into glaciers. Australia and Asia were once joined, lands revealed by oceans stepping back. Then, in moments of hidden release, those connections vanished again under seawater. Civilizations thousands of years later were built on coastlines only possible because of the sea's oscillating pauses between cold and warmth. In this way, the ocean was not simply a reflector of ice ages. It was their sculptor, adjusting which landscapes existed, and which never would. Even our atmosphere's changes across glacial cycles were oceanic at their core. Carbon drawn into the sea during glacial maximums lowered the greenhouse blanket above, sharpening the chill. When stratification or shifting salinity disrupted storage, carbon returned, filling air, warming planets, melting glaciers. The library of shells and corals still records this. Oxygen isotopes show the rise and fall of ice sheets working in precision with ocean ventilation. Carbon isotopes show the push and pull between atmosphere and abyss, like a breath oscillating between inhalation and exhalation. What if life itself is but a passenger, seated within these oscillations, carried unknowingly on the lungs of oceans? Perhaps most haunting is how sudden the transitions appeared in local time. For thousands of years, conditions could be steady, frozen, unyielding. And then, within decades, the ice retreated, seas rose, climates shifted, ecosystems reassembled. An age of silence undone by a century of release. The locked heat had returned. The ocean, patient as ever, did not resist entropy forever. It allowed its balances to give way, and in doing so rearranged the entire stage of Earth's story. When we look out at oceans now, we may forget that stored in their depths could be the faintest seeds of cycles yet to come. Whether another great glaciation will rise depends not only on orbital geometry, not only on greenhouse burdens, but on how the ocean chooses to hold or release its memory. Glaciers are anchored not in ice, but in currents. Ice ages are written through dialogues between salt, density, and carbon chemistry. Could it be that the seas know more about frozen epochs than the ice sheets themselves? The truth, drawn from deep sediments and Greenland's ice alike, suggests that our planet's frozen silences and sudden thaws emerge less as random chance, and more as rhythmic conversations between water and air. The sea stores warmth in darkness. The sea returns it in light. The memory of those ages remains inscribed in isotope trails, in shells no larger than sand, in mud packed tight beneath abyssal plains. Entropy presses every cycle toward dispersal, but dispersal only prepares the next order, the next balance, the next climate that life will call home. And yet, if oceans can carry entire ice ages within their circulation, if they can time the opening and closing of epochs we mistake for permanent, then perhaps the question stretches even deeper than glaciers. What of the forgotten climates before ice ever came? Epochs not of frozen silence, but of warmth so permanent it seemed unbreakable. What might those oceans, long vanished, still be whispering to us in the fossil record we have yet to read? Within memory of that distant warmth we find another mystery, one hidden not in the poles but in the shadowed middle depths of the seas, the oxygen minimum zones. These are places where the ocean breathes less freely, regions of suffocation so vast and so quiet they resemble deserts, invisible from the surface yet sprawled out across entire basins. Roughly a few hundred meters down, where sunlight fades and photosynthesis ceases, waters can become still, sealed away from currents that would otherwise refresh them with oxygen. Their respiration by drifting plankton and bacteria consumes what little oxygen is left, until the water holds almost none at all. Fish avoid these regions. Larger creatures rarely cross them. Life falters not because there are predators, not because of storms, but because the chemical foundation of survival has thinned to near nothingness. What if the ocean were to expand these shadow deserts wider, higher, closer to the surfaces we know? Could entire ecosystems vanish simply from the slow dwindling of invisible breath? Oxygen minimum zones are reminders that the balance of air and sea is fragile. The ocean produces much of the oxygen we breathe through plankton blooms nearer the surface, yet the mid-depths teach us how close the circulation always is to collapse. Just a small shift, warming waters holding less oxygen, changes in current slowing replenishment, can tip vast regions into suffocation. The cores of ancient sediments reveal that such expansions have happened many times before. During warming epochs, oxygen-poor water spread, leaving behind layers of black shale, sediments saturated with organic matter that could not be consumed because oxygen itself had vanished. These layers are tombstones of suffocated seas, reminders that even air itself is vulnerable within the ocean's dark metabolism. There is something haunting about the silence in these regions. Unlike storms or eruptions, they are not acts of violence but of absence. They are defined less by what is present than by what is missing. No air, no sound of fish schools, no growth of corals, only drifting microbes slowly feeding on the last remnants of decay. Entropy plays its quiet hand here, not through chaos but through depletion. Perhaps that is the greater mystery, that collapse can arrive not with noise but with stillness, not with eruption but with suffocation so subtle it appears invisible from above. The resilience of life is still written here, however. Creatures have adapted in remarkable ways to survive. Some fish travel only at night through these zones, minimizing the hours they must endure thin air. Some microbes thrive anaerobically, eating chemicals like nitrate instead of oxygen, reshaping the chemistry of entire regions in the process. Even suffocation holds diversity, though of a kind unrecognizable by ordinary standards of abundance. Could it be that life, in its persistence, is always preparing to adapt even to suffocation, recording its existence in ways we can only faintly glimpse? Maybe not. And yet, the oxygen minimum zones are not confined to these depths alone. They reach outward, exerting influence on weather above. Patterns of oxygen shortage shift nutrient balances, altering how plankton bloom at the surface and how much carbon they draw down into the deep. The balance of air above, oxygen in our lungs, carbon in our atmosphere, emerges from interactions with deserts of suffocation far beneath. What appears to us as breathable sky is, in part, the legacy of unbreathable water. The link is delicate, unsettling, beautiful in its fragility. To think of this is to realize again that the ocean does not guarantee its services. It does not promise oxygen, carbon absorption, or balance. It lives at thresholds, always with currents that can falter, with chemistries that can shift, with deserts that can grow. It resists, but only for so long. It delays entropy, but never cancels it. In this way, oxygen minimum zones are not anomalies. They are reminders of how precarious balance truly is, how the breath we take holds within it the possibility of frailty, silence, collapse. And yet, if suffocation shadows even the living sea, if silence can creep through mid-depths where light itself barely reaches, then what of the surface above, the atmosphere stretched over us like a thin skin? What forgotten chemistries, what shifting balances of gases, might still lie hidden in the long memory of ancient skies? To follow that thought brings us to the monsoons, those immense seasonal breaths of earth where ocean and atmosphere entwine in a rhythm so large it shapes not only weather, but the story of humanity itself. For monsoons are not simply storms, nor just rains. They are the pulse, the inhalation and exhalation, of continents responding to the sea's heat. Each year, as the sun drifts north and south, the land warms or cools faster than the water beside it. Air, heated over continents, rises, drawing moist winds from oceans toward shore. The result is monsoon, a reversal of winds, a surge of rains that seem almost alive. Entire civilizations have been built upon their timing. When the rains come steady, rivers swell, crops flourish, people thrive. When they falter or arrive too late, famine sweeps quietly across fields, migrations ripple outward, and cultures shift. Could it be that much of human history, the growth of empires, the collapse of kingdoms, the silent footsteps of wandering peoples, has been less about ambition and more about the heartbeat of monsoons, guided by oceans below? What gives the monsoon its power is not simply the surface, but the slow warmth stored in the deep sea. Ocean heat absorbed in the tropics lingers, redistributed by currents, carried north or south, stored in abyssal reservoirs invisible to us. That warmth emerges through seasons, driving evaporation, thickening the monsoon's clouds, fueling its intensity. In this way, the quiet patience of the sea translates into thunder and rain. A peasant waiting with seeds and soil, a city counting its grain, a family praying for water. All of them lean unknowingly on the deep sea's ability to keep, and then give back, its warmth. The paleoclimate record shows us just how profound this link has been. Cores from Arabian Sea sediments reveal layers rich with organic matter deposited when monsoons were strong, feeding sudden surges of plankton and life. Layers thin when rains falter, when winds weaken, when the land hungered for water and received only dust. Fossil pollen from ancient lakes in India, in Africa, in China bears the same story. Forests swelling and shrinking with monsoon rhythms, grasslands shifting, deserts advancing or retreating depending on whether oceans had delivered their heat to the skies above. Is it possible, then, that even myths of floods and droughts, the ancient cycles of feast and scarcity, were themselves memories of monsoons echoing through generations? Civilizations inscribed their hopes into these climates. The Indus Valley flourished for centuries, rivers fed by generous seasonal rains. Yet when monsoons weakened, its rivers shrank, its cities emptied, its people dispersed. In West Africa, kingdoms rose with the greening of the Sahel when rains were abundant, then declined when drought returned. In China, dynasties recorded famine following years of disrupted floods. We imagine cultures rising through human will alone, but paleoclimate whispers another truth. Monsoons have dictated harvests, drawn lines between security and collapse, sculpted the pathways of migration across continents. Not because people lacked resilience, but because no will can override water when it ceases to fall. The monsoon itself, however, is never permanent. Its strength waxes and wanes with cycles larger than a lifetime. Orbital patterns tilt sunlight differently, altering ocean warming, and so the rains follow centuries of abundance or centuries of scarcity. Volcanic eruptions inject aerosols, cooling seas, altering rainfall for decades. Greenhouse gases shift circulation, turning oceans warmer than history has seen, feeding new uncertainties into the pulse. Sometimes monsoons collapse swiftly, leaving centuries dry. Other times, they return with violent floods, overcompensating for years of missing water. Maybe not. Yet the sediments show us this truth again and again. The pulse is irregular, long, mysterious, not bound by the calendars we keep. Still, humanity persists inside this rhythm. Languages, cultures, and even chants and songs carry the reliance on rains, stories told to mark when they came, when they withheld. Entire temples are aligned with monsoon winds. Agriculture itself can be read as a contract of trust with these seasonal breaths. And though societies are modern now, with dams and irrigation, satellites and forecasting, we are not separate from the deep sea's dialogue with sky. Rice and wheat fields still bow to this pulse. Cities still feel the flood or the drought. The oceans continue to fuel the breath of heavens, and the heavens decide what we gather from the soil. Perhaps what is most humbling is that these rains, vast as they are, emerge from the fine physics of evaporation and circulation, the hidden gifts of heat stored slowly and then given suddenly. Monsoons are not erratic storms, but echoes of patience. They remind us that the atmosphere is less a blanket and more a conductor, translating the slow warmth of oceans into something audible, visible, tangible. A season, a harvest, a reprieve. And yet, if monsoons are the pulse of the sea translated into sky, if they guide the fate of harvests and migrations, then what of the times when that pulse fails entirely? What hidden lessons might still lie in the ancient record of droughts so long, so absolute, that they remade continents and erased worlds we no longer recall? To glimpse those lessons, we must look not in clouds, nor in rivers, but in the quietest place of all, the ocean floor. For even in crushing depths, where darkness is eternal and pressure is fierce beyond imagination, there are traces waiting. Shells fall there, drifting through the slow night, settling one atop another. Over time, they create fossil archives in sediments. They are not loud monuments, not carved stones or written alphabets, but silent messages from surface waters, preserved in a language of calcium and isotopes. It begins with plankton, microscopic creatures floating in sunlit waters. Invisible to our eyes, they are countless, and as they live, they record. Each tiny shell is built from calcium carbonate drawn out of seawater, each fraction of oxygen isotope sealed inside reflecting the temperature of the water at that exact moment in time. When the plankton die, their shells sink. Some dissolve, some are eaten, but enough survive to drift for days or weeks, finally landing on the floor of the sea. There, they rest, undisturbed, joining millions upon millions, layering into archives that stretch back millions of years. It is not intentional. It is not storytelling as we know it. And yet, taken together, they form diaries of climate, uninterrupted, waiting silently to be read. The abyss is cruel, but in its cruelty lies preservation. At depths where sunlight never breaks, the surface's chaos is muted. Storms do not reach. Waves do not disturb. The shells of foraminifera and coccolithophores, fragile as dust in a fingertip, survive, pressed into sediments. Their chemistry endures. Oxygen isotope ratios telling of sea surface temperatures, carbon isotopes revealing productivity, even hints of ancient rains and winds expressed in the dust that accompanies them down. Entire epochs can be read in cores lifted from seafloor, each centimeter representing centuries, each meter layered with climates lost to human history. Could it be that the abyss is the truest historian, the only witness who keeps memory in silence, by simply holding on? Fossils of the abyss are unlike bones on land, which erode, scatter, or decay into absence. These fossils are infinite repetitions, a billion tiny shells, no larger than sand grains, anchoring climate truths beyond any myth. In them lie the signatures of ice ages waxing and waning, of sudden collapses in circulation, of monsoons failing and then roaring back. The smallest organisms have recorded the largest changes. Perhaps this is the greatest paradox of memory, that those who never intended to leave a trace ended up preserving the most faithful record of all. There are stories hidden here that unsettle. Sediment cores drawn from the Pacific and Atlantic reveal times when the ocean itself nearly suffocated, when oxygen minimum zones expanded, turning seas stagnant. The shells present there show changes in isotopic balance, sudden spikes in carbon release, whispers of an atmosphere that shifted sharply, enough to unravel ancient forests and starve reefs of resilience. Evidence of extinctions sits side by side with evidence of rebirth, epochs collapsing into tiny white remnants. Entropy, again, etched gently into calcium, scattered but not erased. Maybe not. And yet each layer is proof that nothing passes without leaving a trace somewhere. To hold one of these shells in hand, no larger than a speck, is to cradle time. Inside, the ratios of atoms speak of oceans warmer or cooler, saltier or fresher, storm-swept or stagnant. Scientists with mass spectrometers tease out meanings, but even without instruments, the idea itself is overwhelming, that something so fragile could hold the memory of whole climates, survive pressures stronger than steel, and deliver its message across millions of years. What does it suggest about memory itself? That perhaps it does not require size or strength or even intention. Perhaps memory only requires persistence, a willingness to endure. And still, even fossils of the abyss are not eternal. Subduction drags seafloor downward, burying archives into mantle heat, erasing them into fire. Entropy gnaws, dissolving shells into carbonates again. What is preserved is never permanent. What is erased may someday return in volcanic gases, transformed but not gone. The abyss provides stability only for a time. Yet in deep time that is enough, more than enough to knit a planetary story from fragments. And yet, if the smallest creatures of the sea can leave memories vast enough to map climates and epochs, what of the largest? What fingerprints might the leviathans, whales, once countless, have left upon the ocean, invisible archives carried in migrations, in bones, in echoes as deep as trenches? To answer, we must widen the lens beyond ordinary life and toward extraordinary endings. For every ocean archive is not written only in growth and continuity, but in collapse, in sudden shocks, in silences so stark they cut through the slow rhythm of deep time. The ocean is not only the keeper of life's memory, it is the archive of catastrophe. When an asteroid struck the Yucatan 66 million years ago, fire rained from skies. But more than fire followed. Dust encircled the earth, sunlight faltered, plants withered, and food webs collapsed. On land, creatures perished. But in the sea, the catastrophe can still be read today. In sediment cores, there is a line, thin, dark, unmistakable. A layer enriched in iridium, born of the asteroid's body, followed by a sudden vanishing of fossil plankton above it. Tiny shells that had carpeted the oceans are missing in that stratum, absence as eloquent as presence. It is silence made material, compressed into clay, still visible to anyone who can read. Could it be that extinction itself echoes more loudly than survival, crystallized in a single line too sharp for eternity to blur away? Maybe, maybe not. But the ocean remembers, even when land has long since eroded the same years into dust. Other catastrophes whisper in similar ways. Volcanic winters, when eruptions spread ash and sulfur high into the stratosphere, dimming Earth's light for decades, left their record here as well. Beneath the surface, the ocean's conveyor shifted, circulation slowed, nutrients changed. Sediments mark these episodes in sudden blooms of organic matter when waters grew stagnant, or in barren gaps where nothing seemed able to thrive. In times of great volcanism, entire cycles of carbon shifted into imbalance, written as abrupt spikes in isotope trails. The ocean holds these messages as though stitched into its layers, reminders that catastrophe is not only chaos but also chemistry redistributed, order dissolved into memory too delicate yet unforgotten. We tend to think of disasters as isolated moments, as a single impact, a single eruption, a single shift. But in the ocean archive, catastrophe is elongated. The shock stretches out for centuries, sometimes millennia, as systems recalibrate. Darkness above starves plankton. Less rain falls on land. Fewer nutrients flow into rivers. Currents waver. Oxygen thins. The catastrophe that unfolded in weeks or months lingers as imbalance within the sea for ages. The archive is less about the explosion itself than its echo, carried forward in every change of density, every deviation in isotopic balance, every layer where fossils break and falter. And so the sediments tell us this: catastrophe is inevitable, but also survivable. Life always continues, though altered. After the asteroid, plankton eventually returned. Foraminifera, once obliterated, began again in new forms. Ecosystems reshaped. The dark layer in sediments is followed by a lighter one, filled once more with shells. The ocean's diary reveals endings not as punctuation, but as commas, pauses in the long sentence of evolution. Perhaps entropy requires this, that collapse clears the ground for new arrangements, that disorder is only another rhythm in which life rewrites itself into persistence. The fossils whisper of forgotten collapses too, smaller perhaps, but devastating nonetheless. Times when methane released suddenly from frozen hydrates on the seafloor, driving sharp warming. times when currents faltered and suffocated abyssal plains. Each one left a line in sediment, black shales, isotope spikes, altered chemistries. And while we may not know the precise details of each death, the ocean itself remembers as best it can, layering testimony quietly across thousands of meters of mud. To look into these cores is to realize the ocean is less like a historian and more like a witness. Calm, impartial, never intervening, but recording all events, ordinary and catastrophic alike. The humbling thought is this: catastrophe has always been folded into the natural rhythm of Earth. If oceans could speak, they might remind us that their archives are filled as much with silence as with continuity. What appears to us like extraordinary rupture is, to the scale of deep time, only variation. The asteroid line, the volcanic ash, the sudden blackness of suffocated seas. All of these are only layers, one upon another, in continuity so vast it dwarfs the drama of collapse. Still, for those who lived in each moment, whether dinosaurs, trilobites, or us, the catastrophe must have felt permanent, final, unbearable. But the sediments assure us, permanence is an illusion. Nothing stays lost forever. It only shifts into new forms of record. And yet, if oceans can preserve catastrophe so faithfully, translating extinction into thin bands of memory, what else might they be keeping hidden? Records of events not yet understood, disasters too subtle or too alien for us to comprehend. Is it possible the ocean remembers more endings than even geology can translate, holding within its abyssal libraries the quiet truth of how many worlds before ours have risen, burned, and fallen into silence? Perhaps the truest guardians of Earth's story are not the mighty continents or the deep trenches, but something far smaller. To find them, we must look not at the ruins of catastrophes, but at the invisible architects who shape the climate itself. Not mountains, not forests, but plankton and algae adrift across the sea. These are the planet's invisible climate engineers, guardians so small we overlook them, yet so powerful they can alter the balance of air. When we think of oxygen, we often turn to forests, to jungles breathing outward, to green canopies that stretch across land. But more oxygen than any leaf or tree will ever produce comes from the drifting life of the sea. Phytoplankton, microscopic algae bathed in sunlight, photosynthesize at a scale so immense it becomes incomprehensible. Every second, they are drawing down carbon dioxide, folding it into sugars, and exhaling oxygen upward into the world. With each sunrise, they transform vast surfaces of sea into active lungs. We breathe now, in this moment, not because of distant rainforests alone, but because countless invisible cells beneath the water have chosen, in the quiet machinery of their chemistry, to gift us air. Could it be that the greatest forests have always been oceans, stretching endlessly, rootless, unseen? Their influence extends beyond oxygen. When plankton die, their bodies, laden with carbon, drift downward like snow. Some are eaten, recycled instantly. Others fall deeper, joining sediments, carrying atmospheric carbon down into storage. Over millions of years, this sinking created chalk cliffs, limestone ranges, carbon locked into stone. Over shorter spans, it created the balance of climate itself, seesawing between greenhouse and icehouse states depending on how much of that invisible snowfall reached the bottom. These organisms, smaller than dust, control cycles larger than empires. Maybe not. But without them, the sky above us would be unrecognizable, thick with gases we could not survive, stripped of the balance that has allowed life to rise and persist. Some plankton do more than cycle carbon. Certain species emit compounds, dimethyl sulfide, that drift upward when released, seeding clouds over the sea. Clouds reflect sunlight, cooling the planet, altering weather systems. A molecule born in the metabolism of algae can ripple outward into atmospheric shifts vast enough to change wind belts, monsoon strength, even patterns of rainfall over land. Could it be that clouds themselves are less the work of air and more the breath of ocean drifters, calling faintly up to the heavens and bending climate to their will? Perhaps this is the Earth's strangest truth, that scale does not dictate impact, and that the smallest beings are those who most shape the fate of the largest systems. The archives of deep time remember this, too. When plankton flourished at massive scales, carbon dioxide fell, ice advanced, and seas cooled. When they perished in mass die-offs due to changing chemistry, heat rose, oxygen faltered, extinctions followed. Their presence and absence are written as isotope swings, as chalk deposits, as black shales dense with organic carbon buried hurriedly in stagnant seas. At several points, entire epochs were defined less by tectonics and more by these quiet architects. Their survival or collapse shifted the trajectory of Earth's climate. Our own inheritance comes, in part, from their persistence during past catastrophes, from their ability to endure chaos. If they had failed entirely, perhaps forests, animals, even us, would have had no atmosphere in which to appear. Even now, their fragility is a reminder of balance. Acidification alters the way shells form, thinning them, making them vulnerable. Warming waters push species northward or southward, unsettling food webs. And yet they persist, even through change. Microbes, algae, coccolithophores, diatoms, they adapt quickly, writing every adjustment into their bodies, passing climate memory into carbonate and carbon trails that will one day fall to abyssal floors. They remind us that climate itself is not an abstract system but a dialogue sustained by living matter. Perhaps there is comfort in this, that oxygen carries with it not only the work of trees or grass, but the memory of oceans whispering upward, filling lungs that will never see the sea. Each breath we take carries part of their invisible guardianship. We live within their generosity, whether we notice or not. And so vast is their contribution that our perception of climate might be reversed. The air is not what shapes the sea, but the sea through drifting microscopic lives that sculpts the very air we inhabit. To see plankton and algae this way is to glimpse Earth's hidden guardianship, a distributed intelligence without awareness, a collective system balancing gases across the skin of the world. They do not mean to protect. They do not choose to regulate. And yet the consequences of their cycles are so profound that we may as well call them guardians all the same. Could it be that climate stability is not just about rocks or currents or stars, but about clouds of organisms floating quietly, endlessly, sustaining the very idea of breath? And yet, if the smallest, most invisible of beings can shape air and climate at planetary scale, what of us, large, loud, and transient? What fingerprints are we inscribing into the ocean and atmosphere? Fingerprints that might drift forward into deep time, leaving behind not guardianship, but technofossils of our own making. To follow this unsettled trail is to arrive at one of the ocean's most haunting mysteries. Not just its chemistry, not just its biology, but what human history it has chosen to swallow whole. For while mountains keep their ruins on the skyline, the seas remember differently. The ocean is also an archive of lost civilizations. Across myths and folklore, fragments of this truth persist. Tales of sunken kingdoms, of drowned forests, of coastlines reclaimed by water, may sound like fantasy, but they echo real cycles of climate that have raised and lowered sea level again and again. During the last ice age, with so much water bound in glaciers, the seas were more than 100 meters lower than they are today. Whole landscapes now hidden beneath the continental shelves once thrived with life, forests stretching far outward, rivers carving deltas in what are now drowned valleys. When the ice melted, the ocean returned, sweeping over shorelines, burying homes, erasing fields, pulling memory into silence. What if many of the stories of deluge, of floods sent by gods, of vanished lands swallowed in a single night, are echoes of ancient coasts slipping beneath rising tides? Here and there, the evidence lingers. Divers have glimpsed submerged structures off the shores of India, Japan, the Mediterranean, some remnants of temples and dwellings, others natural shapes mistaken for walls and steps. Yet even beyond ruins, the ocean floor preserves subtler truths. Ancient beaches now hundreds of meters below, terraces of rock once smoothed by waves, caves marked by human handprints long since drowned. The myths of Atlantis may be more allegory than fact, but the broader idea rings true. Civilizations, however mighty, build on coastlines, and coastlines eventually are erased. Not because they are cursed, not because they sinned, but because seas never stop moving. Sediments, too, write their own version. Layers of pollen beneath shallow seas trace forests that stood where waves now roll. Fossilized corals, drowned in place, reveal the precise pace of rising sea levels, corals growing as ocean crept higher, then collapsing when water rose too swiftly. To hold these fossils is to glimpse lives erased without witness, endings without chronicles. Could it be that much of human prehistory, whole cultures before writing, now rests inaccessible beneath silt and tide? Maybe, maybe not. But it is almost certain that the ocean conceals memories of peoples long vanished, their presence preserved not in myth alone, but in stone. And yet the ocean does not erase without also preserving. In its darkness, artifacts wait, sealed from decay. Wooden ships, sunken under wartime fire or slow attrition, rest intact on the seabed, their timbers untouched by rot. Pottery, bones, even city walls endure, shielded by sand. The ocean buries, but in burying, it protects. The memory is present, out of sight, but not destroyed. Each discovery hints at a larger archive still held by the sea. Harbors no longer visible, roads that led inland and now end in water, market squares filled with silence. The earth is always changing, but the sea, in rising, has hidden more history than we have yet uncovered. Consider, too, the role of entropy, which we often call the eraser. On land, ruins crumble under rain, stone is scavenged, dust swallows foundations. But underwater, entropy acts differently. By preserving absence of oxygen, by stilling processes of decay, the ocean sometimes resists disorder. Objects lost to the waves may endure far longer than they would on dry soil. What we call sunken ruins might one day outlast their surviving counterparts on land. Is it possible that the most faithful record of us will not be monuments under the sky but those concealed beneath the sea? In this way, the ocean holds not only geological and biological memory but cultural memory as well. It has archived our migrations, our cities, our catastrophes. Low-lying regions that once thrived are gone. Doggerland beneath the North Sea where people once hunted. Sundaland near Southeast Asia where vast plains supported life. Beringia bridging Asia and the Americas. These are not just landscapes but entire chapters erased from maps. Chapters for which myth is our only surviving narration. And yet, the seabed carries their outlines still, ghostly echoes waiting in submerged valleys, waiting perhaps for someone to read them. Perhaps what makes this humbling is not the idea that civilizations vanish, but that they vanish so quietly, leaving only suggestions. The silence of a drowned harbor, the stillness of a wall seen only by divers' lamps, the absence of stories where stories must once have been abundant. What if most of human history is already gone, stored in darkness, inaccessibly distant, yet preserved in its own way? And what if, long after us, future intelligences, not necessarily human, sift the seabed and find traces of our world in the same way we now find theirs? And yet, if the ocean has swallowed civilizations while still keeping hints of them beneath stone and sand, what does that suggest about memory itself? That erasure is never absolute? That silence is only another form of keeping? If so, then perhaps beneath the shifting shorelines and drowned cities lies a deeper thought. The ocean does not only protect what it buries, but waits, patiently, for us to learn how to listen to what has been hidden. And if so much of our past is there, what else, still deeper, still darker, still untouched, might be waiting? If so, then we must also ask a quieter, more unsettling question. What of the memory the ocean now keeps of us? Not in myths of cities washed away or carved shorelines drowned, but in substances stranger and more enduring. For while the ocean has held fossils, isotopes, and ruins across time, it is now layering something altogether different into its abyss. Plastics, soot, radionuclides, all are descending into its depths, forming sedimentary chapters unlike any that have come before. The ocean has begun to carry our technofossils, the artificial memory of the age we call our own. Walk along any tide line, and you will see them already. Fragments of plastic worn soft by waves, bottles eroded to translucence, threads of synthetic fibers tangled among seaweed. They drift outward, broken into smaller and smaller pieces, until they sink, absorbed into sand or drawn downward into the abyss. There, they settle like plankton shells once did, indistinguishable in scale but alien in origin. In the sediment layers of the future, a new stratum will appear. Not chalk, not silt, not pure shell, but plastic polymers fused with organic matter, pressed under pressure into a strange hybrid stone. Could it be that our most lasting geological legacy will not be cities or monuments, but fragments of plastic drifting eternally, waiting to be recognized as fossils of us? But plastics are only part of this layer. Other signatures arrive too, carried from the air to the ocean. Soot from factories, from engines, from fire, rains down as fine black dust, particles woven into deep-sea mud where none had fallen before. Radionuclides from nuclear detonations have spread across the earth, carried by rains and rivers until they entered the sea. Even though their half-lives span centuries, their traces will endure for tens of thousands of years, subtle, unmistakable isotopic markers that will one day allow anyone, or anything, to pinpoint the mid-20th century as a geological threshold. A line in the ocean sediments sharper than the iridium of asteroid impact, sharper than volcanic ash. Our signal is already there, and still deeper traces spill outward, too. Heavy metals from mining, fertilizer nutrients, carbon isotopes shifted abruptly by fossil fuel burning, all now flow into oceans and record themselves in chemistry. Coral skeletons carry altered isotopic signatures, marking the abrupt acceleration of greenhouse gases. Marine snow, falling endlessly into the ocean depths, entangles pieces of plastic alongside foraminiferous shells, a mingling of natural memory and artificial permanence. It is a new climate record, a new geology, one where entropy has been bent by human invention. Perhaps the most strange detail is how quickly this memory has been written. Other epochs, ice ages, extinctions, warmings, reorganizations, entered the ocean's record over tens of thousands or millions of years. Our technofossil layer, by contrast, has appeared in less than a century. It is a geological instant, a breath, and yet it spans every sea, from Arctic pack ice to abyssal plains. Already, cores drilled from the seafloor show thin plastic fibers embedded where no human has ever passed. Already, mussels and fish carry particles within their bodies, echoes of polymer storms. Could it be that this is the first time the Earth itself is aware of us, not through myths, not through fossils, but through signatures so deliberately unlike anything grown or eroded? Entropy has its own irony here. Plastic resists decay, soot endures drift, radionuclides take ages to fade. Our creations, fleeting to us, linger in Earth's chemistry far beyond the span of our lifetimes. And yet the irony deepens. These relics may one day serve as faithful records, as fossils do, whispering back to future readers that once there were creatures here who rearranged carbon and shaped the fate of seas. Not because they wanted to leave a record, but because they could not avoid it. Maybe that is what we are, the only species that cannot help but leave a trace. What if memory is not given but forced? What if the ocean does not want this record, but must keep it because there is nowhere else for it to go? Plastics drift and sink, soot dissolves into sediments, isotopes bind with shells, whether or not the ocean agrees. Our memory presses into its archive by gravity alone. It will hold us for longer than we will hold ourselves. And yet, beyond thought of guilt or permanence, there is still awe. For here, in the ocean's library, the page is open and being written even now. A strange new chapter, the technofossil age, unfolding beneath silence. Future geologists, whether human or other, may drill into seafloor cores and find this era unmistakable. A thin band of polymers, soot, and isotopes, the sudden signature of a restless species that touched every element of Earth in only a blink of time. And yet, if even our brief technological age is written already into the ocean's sediments, if the sea itself now carries our inventions in its abyss, then what might come after us? What new layers will be laid upon our technofossil band? What next archives will press above, recording yet another age we cannot foresee? To sense the future, perhaps we must look upward, not downward to stone or sediment, but toward what is already moving restlessly all around us. For the ocean is never truly alone. It is always speaking, always trading, always entangled with the restless sky above it. Every moment of contact between ocean and air is an exchange. Molecules shift, heat rises, water evaporates, currents stir wind into patterns we call weather. Where the sea is warm, the air carries that warmth into storms and hurricanes, some spinning with force enough to redraw coastlines in hours. Where the sea is cold, calmness spreads, winds quiet, rainfall fails. The air and the water do not act separately. They are two halves of one long rhythm, inseparable, infinite, a dialogue that has lasted since seas first gathered, since skies first thickened around this planet. Could it be that all the climates we have ever lived within are only the conversation between ocean and sky, written above and below simultaneously? Maybe, maybe not. But the rhythm is undeniable. Consider how every storm, every cloud, every rainfall begins not in the sky but at the surface of the sea. Heat from sunlight lingers in water longer than it does on land, and as it escapes again into the air it fuels winds, feeds monsoons, dictates rainfall thousands of miles away. Fishermen in the tropics, ancient farmers waiting for seasonal rains, sailors watching shifts in the wind. They were listening unknowingly to the ocean's secret gift to the skies, to the gentle exhalations of seas becoming weather above them. Storms may sound like tempests in the heavens, but they are born of oceans remembering the sun. And still, the sky leaves its imprint on water. Shifts in pressure push seas into new circulations. Dry winds steal moisture, leaving saltier, heavier waters behind. Dust from deserts falls into seas, delivering nutrients that spark plankton blooms, which then change gases in the air once more. The exchange continues endlessly, with no clear origin, no beginning, no end. Perhaps this is why the image of Earth as a blue planet is incomplete. Its blueness is never sheer ocean, never sheer sky, but emergence, a gradient shifting constantly between them. Science reads these exchanges in isotopes, in molecules cycling through rain, cloud, and wave. Tracers show exactly how water once touched the ocean before falling inland as rain, how carbon dioxide entered the sea before drifting back into the sky as altered chemistry. In ice cores and soils, we see that oceans have always dictated the fluctuations of atmospheres, the way storms grew or shrank, the way rainfall wandered across continents. Could it be that even the rise and fall of ancient civilizations, those that thrived or failed depending on floods and droughts, were written first not in the earth they tilled but in the sea-air dialogue they could not see? Maybe, maybe not, but the memory suggests it. The restless sky is not always violent. Just as often it is silence, the slow movements of jet streams reshaped by ocean currents below, the subtle humidity that recalls distant evaporation, the quiet weight of stillness before rain arrives. To live through climate is simply to live inside these exchanges, felt in our breathing, echoed in our skin, carried through seasons without our noticing. We think of them as external weather, but they inhabit us too, as much as we inhabit them. Philosophers might wonder if memory itself exists not only in objects and fossils, but also in patterns. Wind passing warmth it has carried for days, clouds carrying imprints of dust from halfway across the world, raindrops holding faint traces of ocean salt before sinking into soil. If memory lives in the invisible, then perhaps the sky is one of its greatest libraries, archiving not by permanence but by rhythm, repeating endlessly, whispering what the ocean has already spoken. Air and water chase each other, fold into each other, resist and respond, always together, always turning balance into imbalance and back again. In this, there is no hierarchy, only rhythm. Every cyclone, every snowstorm, every drought, every flood emerges from them. The surface is not only the boundary between them, but the page upon which they both write, sometimes in lightning, sometimes in silence. And yet, if air and sea are so inseparably woven, if their dialogue is what makes weather, climate, and atmosphere, then what of the distant past, epochs when the sky itself was unrecognizable, thicker, thinner, stranger than now? What forgotten skies might the ocean still be remembering in its restless exchange? To find the answer, we must return once more to the water itself. For every trace of Earth's climate, archived in stone, in fossil, in ice, begins first with the circulation of the sea. In many ways, the ocean is not only the engine of change but also the mirror of it. the reflection through which Earth remembers what it has been and whispers what it will become. Each isotope, each fossil, each layer of sediment drilled from the Earth, carries within it some imprint of the ocean's movements. The tilt of the planet, the drift of continents, even the faint variations in the sun's intensity, all of these influences pass through seas before they leave their mark upon stone. Climate does not emerge first on land, but in the vast swaying body of water that redistributes every imbalance across its depth. When seas are warm, glaciers falter, forests expand, deserts retreat. When seas are cold, ice advances, rainfall thins, life constricts. The ocean reacts, reflects, and stores, then passes its memory forward for rock and ice to record. In this sense, to read the climate in stone is always to be looking at a mirror that once belonged to the sea. What if the ocean is not merely a participant but the translator of the planet's story? The speaking surface, the deep reservoirs of silence, the currents that ferry chemicals from one hemisphere to the other, each of these elements turn raw physics into the rhythms we call climates. Could it be that, without the ocean to reflect them, the faint wobbles in Earth's orbit, the rises and falls of carbon, the eruptions and impacts, would have passed unnoticed? Maybe, maybe not. But all archives beyond the ocean bear its signature, as if it were memory's great intermediary, reflecting every distant change into the fabric of planetary life. The ocean carries memory forward not only in chemistry but also in its very motions. Circulations restore or collapse, monsoons falter and strengthen, glaciers grow or retreat, all paced by the slow rivers folding heat and salt beneath the surface. Scientists reading isotope trails from coral reefs or fossil shells are in fact listening to the ocean's echo, a diary it has written not for us, but for itself. Every storm we see today, every shift in rainfall or wind, is a reflection of patterns that have always begun in water. We gaze at the sky, but the mirror is held below us, not above. And yet, this mirror does not only reflect what is, it anticipates. Oceans absorb heat invisibly, hold it for decades, centuries, then release it again, setting into motion climates that shape futures not yet lived. The stone and ice that will one day record the next shifts are already being scripted in circulation now. In this way, the ocean looks not only backward but forward. Its surface is present, its depths are past. Its potentials are unfinished futures stirring quietly in hidden flows. To look at water is to look across time. Perhaps this is why memory itself feels oceanic, mutable, layered, unpredictable. Our recollections shift, fade, distort, yet still hold truths at their core. Not because they are perfect, but because, like the ocean, they reflect as much as they store. Memory is never only what was. It is an image of what may have been, filtered through mirrors and depths we cannot fully sound. Could it be that Earth's own memory works the same, that what we call climate is the planet's recollection of itself, mirrored imperfectly in motion and pattern? Entropy, of course, ensures that nothing remains pristine. Currents break down, sediments scatter, isotopes blur. But reflection does not require permanence. Even a fragment reveals a whole, even a glimpse shows continuity. The ocean, in its ceaseless movements, reminds us that memory is less about clarity and more about rhythm. The details dissolve, yet the patterns endure. Perhaps the truest memories of Earth are not in objects but in mirrors. Water reflecting heat into air, air returning it back into water, each iteration creating echoes that ripple through epochs. The ocean as memory's mirror also reveals our own place within this system. The climates we take for granted, our rains, our growing seasons, the mildness of our coasts, are reflections of balances far below. The warmth we feel now may be heat absorbed centuries ago. The winds we rely on may be drawn from ancient shifts in water densities. What we call the present is therefore a reflection in a mirror tilted slightly away, showing us an image not quite aligned, always containing fragments of past and fragments of future entangled with now. And yet, if the ocean is the ultimate mirror, reflecting Earth's memory across time, then we are left with one final question. What happens when the mirror itself changes? If the seas grow warmer, more acidic, more stratified, What image of Earth's memory will they reflect back to the stone, to the ice, to us? Perhaps no answer captures this dilemma more fully than the corals. For they have been among the ocean's most intricate archivists, keepers of layered chronicles, silent yet precise recorders of what seas once were. But now, their collapse suggests more than loss of life. It suggests the erasure of memory. Corals are more than reefs, more than habitats of color and fish and branching stone. They are living calendars. Within their skeletons of calcium carbonate, each season leaves its band. Narrow lines in times of scarcity, wider bands in times of abundance. Subtle chemical shadings, ratios of oxygen isotopes, trace the warmth of surrounding seas, the salinity of waters passing over them, the whispers of rainfall and evaporation shifting overhead. To study a coral core is to read a diary, as though the reef itself has kept records of centuries in microscopic handwriting. For all of their beauty to the eye, it is their invisible inscriptions that carry meaning into time. Scientists drill into coral heads carefully, extracting slender pipes of skeletons stretching back hundreds of years. Then, with light and chemistry, they trace variations down each band as one might read tree rings. Corals tell us of monsoon cycles waxing and waning, of El Niño events centuries before modern observation, of droughts that altered civilizations. A single colony skeleton can record centuries of ocean rhythms, preserved patiently, layer upon layer. Could it be that we owe our understanding of ocean climate not simply to instruments or satellites but to these silent architects, offering us their own library etched in stone? Maybe, maybe not. But their record feels almost deliberate, as though reefs themselves were aware they were memory's custodians. Yet, for all their endurance, corals now falter under the ocean's heat. Bleaching is more than color drained away. It is memory vanishing from the archive. When waters grow too warm, corals expel the algae that feed them, leaving skeletons pale, hollowed mirrors of what they once were. Some survive, some adapt, but many die, leaving only brittle whiteness where layered records should have continued. If the reefs vanish, the archives vanish too, mid-sentence, mid-story, interrupted not by slow death but by rapid transformation. What does it mean when an archivist forgets its own duty? When the living memory of seas is thrown into blank silence? Isotope trails within bleached corals tell their own story of erasure. The bands stop, patterns blur, chemical continuity breaks. Where once centuries of unbroken data flowed downward cleanly, now gaps and discontinuities appear. It is not merely ecosystems gone, not merely fish and coastlines lost, but centuries yet to be recorded. The ocean itself loses its ledger, cut short by heat. Could it be that we are watching not only coral extinction but climate amnesia, seas stripped of one of their most eloquent keepers? There is a hypnosis in this thought, unsettling in its quietness. For centuries reefs have been constant, their archives growing unnoticed beneath currents and waves. Now they collapse within our lifetimes, reminding us that memory, even when etched in stone, is fragile. Entropy demands decay, but here it is accelerated. It is not slowness but haste, not forgotten over epochs but severed almost abruptly before our eyes. Memory need not fade gently. It can dissolve suddenly, in mere decades, erasing not only its present form but its capacity to record what has not yet arrived. Still, a paradox lingers. Even in their ruins, corals continue to preserve memory. Dead skeletons remain in place, layers retrievable centuries later, showing changes leading up to their own demise. They record their collapse as faithfully as they once recorded monsoons. Bleaching itself becomes an archive, evidence of heat waves, of acidifying seas, of atmospheric disruptions. Perhaps memory cannot be destroyed, only transcribed differently, even if painfully. Maybe, maybe not. But the thought provides a faint solace. Even death in coral form is not pure silence. It is testimony. And what of the lives that depend on corals, the fish swarms, the protection of coastlines, the people who harvest and shelter in their presence? Their stories, too, are layered in reefs. Each collapse writes consequences into societies, into migrations, into histories that will later puzzle anthropologists. The archive of corals extends beyond isotopes. It extends into human movement and adaptation, into silence of traditions lost when seas change too fast. Corals record not only the physics of memory but its philosophy, that memory always carries lives alongside it. So when reefs bleach, when their colors drain and their patterns blur, the ocean is not only losing ecosystems, it is misplacing history. The skeletal bands grow faint. The isotopic diary stops mid-word, and the ocean, long accustomed to remembering everything for us, falls quieter. Perhaps this is the true catastrophe, that extinction does not only remove life but erases time, fractures the chain of memory that connected past to future. And yet, if the archivists of color and stone are collapsing, taking their layered diaries with them, what archives remain? What other keepers of ocean memory, sediments, ice, fossils, even us, might be left to preserve what corals can no longer hold? To find an answer, we must descend again into the fluid body of the sea itself, into the in-between, the altitudes of water where silence thickens, where thresholds lie hidden. For the ocean is stitched not only by currents but by faint, invisible lines of balance. Lines between shallow and deep, between warmth and cold, between oxygen and suffocation. These thresholds, fragile beyond sight, regulate the very possibility of life. And when they tip, it is not only ecosystems that change but climates themselves, irreversibly. The upper ocean, sunlit and restless, seems abundant without end. But descend a few hundred meters and the brightness fades. Within those darker depths are invisible boundaries, thermoclines where warm waters fold into cold, haloclines where salt stratifies, oxyclines where air thins into absence. To pass through them is to enter thresholds as precise as they are delicate. A school of fish may flourish above, but vanish abruptly below. Microbial life shifts species in a matter of meters. The entire distribution of oxygen, carbon, nutrients, and heat depends on the balance of these layers staying intact. The ocean's architecture is a quilt of thresholds, constantly challenged by change. When oxygen tilts toward absence, dead zones expand. Entire ecosystems suffocate quietly, their memory collapsing into silence. Layers of sediment beneath mark these moments, blackened with organic matter unconsumed. Such evidence stretches back tens of millions of years. Epochs when oceans stratified too sharply, currents faltered, and entire lineages of creatures vanished. Scientists reading the isotopes in these layers recognize how sudden the shifts can be. A small warming here, a fresher pulse of meltwater there, and thresholds tip into cascades. Deep waters trap carbon instead of releasing it, or release carbon suddenly where before they stored it. Life adapts until it cannot. Balance holds until it dissolves. Not because the sea is unstable, but because thresholds themselves are precarious by nature. They exist in the narrow spacing of molecules, the subtle weight of saline against fresh, the temperature differences of only a degree or two. And yet upon these tiny lines whole climates rest. Could it be that the fates of continents are decided in the shifting of invisible gradients, in the silence where ocean layers negotiate with one another? Maybe, maybe not. But the sediments speak plainly. When thresholds break, climates follow. Oxygen minimum zones are among the most haunting examples. Expand them a little farther and fisheries collapse. Marine snow fails to decompose. Greenhouse gases build in deep layers until they are exhaled upward in a single sudden torrent. Shrink them and ecosystems bloom again, food chains reform, balances restore. The line between life and loss in these fragile zones is thinner than a veil, and it can tip with temperature shifts so small they might be missed by human senses. But the sea notices always. Thresholds exist, too, in circulation. Conveyors that normally move heat falter when density lines blur. Fresh water from melting ice floats where salt water should sink, weakening, overturning currents. A whole hemisphere's climate can shift when one such hidden seam unravels. Ice ages ended and began with such reorganizations. Civilizations have felt their absence in faltering rains. We think of thresholds as borders, yet perhaps it is truer to see them as hinges. When they shift, the entire ocean's architecture swings open into another form, and the atmosphere above is left to respond. Entropy waits at these seams as well. Order blurs naturally into disorder. Gradients soften until mixing dissolves their distinctions. Without constant energy from winds and currents, the layers would collapse into silence. Perhaps this is why thresholds fascinate us, because they prove that stability is rarely absolute, always the balancing of opposite tendencies, always one step away from scattering. Not because the ocean is fragile, but because life depends on this narrow zone where opposites are kept in tension. Oxygen and suffocation, heat and cold, surface and abyss. And what of us, dwelling on coasts, depending on skies, tied to crops nourished by rains shaped far away? We are participants in these thresholds without ever knowing. Every harvest echoes their chemistry. Every migration has followed their unseen pulse. We rely on them without perceiving them, balanced unknowingly on lines only the sea can feel. Perhaps this is the most humbling thought of all, that human history itself may be nothing more than a reflection carried upon oceanic thresholds, as temporary, as dependent, as fragile as the gradients themselves. The paleoclimate record whispers caution. Dark shales from the Cretaceous seas tell of expanses where thresholds once failed, turning oceans stagnant for thousands of years. Isotope shifts from ancient ice reveal that monsoons faltered when deep water circulation paused at critical lines. Fossil foraminifera change species abruptly at the layers where oxygen dropped. Each archive affirms the same truth. When thresholds tip, change is not gradual. It is swift, decisive, irreversible in human time. What vanishes does not always return. And yet, if thresholds are the lines upon which climates pivot, then what other hidden boundaries might the Earth contain, unrecognized, unimagined? What horizons just beyond our perception might hold back futures so different, waiting only for a slight passing of balance to be unleashed? To seek their answer, we sink downward, far deeper, into the abyssal zones where daylight never lands, where silence is complete, and where the ocean's most secret work continues unnoticed. For here lies what could be called the planet's dark lung, a reservoir not of air but of carbon, buried, locked away, held for thousands of years, determining with each inhalation or release whether Earth inhales warmth or exhales ice. The abyss is not empty. Every particle drifting from the surface, every speck of marine snow, every skeleton of plankton and coral fragment eventually arrives in this darkness. Here, on plains so vast and so hidden we cannot fathom their scale, the world's breath collects. Carbon, drawn down by biology into shells and by chemistry into dissolved forms, slowly accumulates. Most of it remains, sequestered in the water masses of the deep, exchanging painfully slowly with the surface, each molecule beginning a journey that may last centuries before rising again. To imagine this is to picture the ocean itself as a lung too slow for us to notice, inhaling carbon when seas are cold and exhaling it back to the sky when reorganized by heat. In this way, the abyss has always been the quiet partner of Earth's atmosphere. During glacial times, when ice sheets thickened and forests thinned, deep oceans stored immense volumes of carbon, drawing it out of the air and locking it beneath pressure and time. The result was colder skies, drier continents, seas rich in memory of what they had withheld. When warming came, when circulation shifted, much of that carbon rose again, ventilated like a long exhale, filling the atmosphere, melting ice sheets, returning warmth to land. Could it be that the pacing of Earth's great climates was set here, not in the sky but in the breathing silence of the abyss? Maybe, maybe not. But the isotope trails and sediments leave no doubt of the rhythm. A storage, then a release, repeated across epochs. The process is invisible yet exact. Water masses descending in the polar seas carry with them oxygen, carbon, and heat. Once sunk, they drift slowly across entire basins, marking centuries of quiet passage. Isotopes of carbon reveal when they last touched the surface, and oxygen concentrations tell how long they've been absent from contact with sky. Regions high in nutrients hint at how much has rained downward from above, how busy biology has been in cycling and removing carbon into depth. To study these places is to watch the Earth's lungs at work, slower than any patient's breath, yet no less vital, as every exhale and inhale is mirrored in climate itself. And what if these lungs falter? What if circulation slows beyond repair? stratification deepens, and the ocean stops inhaling carbon into its depth. Then the breath would remain above, carbon rising, igniting temperatures that would feel like fever to the planet. What if, the other way, some collapse or reorganization released more carbon than expected, a sudden exhale flooding skies with what had been locked away? Could such shifts explain ancient climate jolts? Times when warming surged at rates that still shock us, when weather beasts moved abruptly across Earth's surface. Maybe not. But the abyss reminds us that memory, when stored, is never permanent. Every inhalation is only a pause. Every exhale will eventually come. The sediments keep testimony. Black layers rich in organic matter say the ocean once failed to ventilate, turning entire expanses anoxic. Lighter layers mark oxygen-rich intervals when circulation lunged back to strength. Carbon isotopes within long-dead foraminifera echo the repeated cycle. It is strange to realize that we can read the abyssal lungs' motions like an EKG across deep time, flatlining in collapse, pulsing again in renewal. And yet, entropy guides even this, urging each system to scatter, to change, to decay, while still leaving the trace of rhythm behind. Perhaps it humbles us most to realize how much our every breath is tied to this dark breath beneath us. The air we exhale, the warmth we feel on a quiet afternoon, the harvest grown by rains. All of them depend on whether the deep ocean is inhaling or exhaling carbon. And we, without knowing, live in synchrony with a rhythm whose span dwarfs empires, languages, even species. In this way, every moment we call the present is threaded backward into unearthed pasts and stretched forward into futures unformed, all bound to the abyssal lung's hidden patience. And yet, if the dark lung determines whether Earth warms or freezes, if its every breath shapes climate for thousands of years, what happens when its chemistry, altered by us, begins to change the very rhythm of the inhalation itself? Is it possible that we are not only shaping the sky above, but shifting the lungs below, and in doing so, rewriting a rhythm older than any memory we have ever known? To ask this is to enter the final question, the one that lingers behind all these stories of tides and fossils, thresholds and archives. What ocean are we leaving behind? What future sea will carry, not only its own memories, but ours? The future ocean will be warmer. That much is already written in its expanding layers and in the slow absorption of heat it has taken from the sky. With every year, surface warmth deepens, mixing downward, altering density and stratification. This warmth is not evenly spread. It pools more strongly in some regions, withheld in eddies, carried deep by subduction lines, hidden for decades before it surfaces again to surprise us in the atmosphere above. Like memory itself, this stored heat will not vanish. It waits, carried forward, to be revealed when we least expect. Could it be that our near future is already embedded in this invisible inheritance, encoded in currents beneath our feet? Maybe not. But the laws of physics assure us the energy remains, to be repaid slowly, in storms, in droughts, in coral whitening into silence. The future ocean may circulate differently as well. Already the great overturning conveyor of the Atlantic shows signs of hesitation. Fresh water from melting ice sheets dilutes its salinity, hindering the dense sinking flows that drive it. In the past, such slowings triggered abrupt transitions, sudden cold spells across continents, weakening of monsoons, migrations of rain belts. If this rhythm falters now, entire regions may swing from abundance to scarcity, from green to dust. The world remembers these shifts in sediments and isotopes, and it will remember again. But this time, the signature carved in stone may bear our fingerprint, as though civilization etched its weight directly into the flows of the earth. Thresholds appear closer than before. Acidity tiptoes toward levels where shells falter in formation, where plankton begin to dissolve before they can serve their purpose as archivists of carbon. Oxygen thins quietly in expanding zones, suffocating fisheries and rewriting the base of food chains. Coral reefs, once vibrant recorders of centuries, bleach into pale fragility, their layered memories broken off mid-story. Could it be that the ocean is attempting to remind us of how narrow the line has always been? That life persists not because seas are stable, but because balance has always been fragile, held together by patience in margins we rarely notice? Still, if all else is uncertain, one fact is eternal. The ocean will remember. It has always remembered, not with intention, not with judgment, but with chemistry and stone. Our century is already inscribed in warming layers, in changing isotopes of oxygen and carbon, in plastics embedded where no living person could ever place them by hand. Deep below, sediments collect our soot, our radionuclides, our microfibers, layering them softly among the fossils of foraminifera and shells. Future readers, whether human or something else, will find this record clear as any line of volcanic ash or asteroid dust. They will know the Anthropocene not as myth but as sediment, a layer distinct, sharp, unmistakable. Entropy ensures this, too. All life leaves a trace, not because it tries to, but because nothing escapes becoming matter, chemistry, record. We may imagine ourselves as fleeting, yet the ocean is already archiving us, already incorporating our restless activity into its diary. Not because it wants to, but because that is simply what it does. It remembers everything. And if so, then perhaps the real question is not whether we will be remembered, but how. Will the sediments tell a story of collapse, of thresholds passed and lungs exhaled too quickly? Or will they tell of adaptation, of slowing entropy, of learning to live within limits long before balance dissolved entirely? Philosophers might say we are already carried inside that memory, bound to it as fish are to currents. Our lives are bent by rains and winds born of seas, our civilizations built along coasts written by tides. We live inside the ocean's reflection without ever truly seeing it. Perhaps one day our descendants will look back into fossils, into sediments, and see themselves more clearly than we can now. Echoes of how oceans once felt, how air once bent, how climates once hovered close to thresholds. Even now, with our footsteps still fresh on sand, the ocean is writing. Each storm carries heat concealed decades ago. Each bleaching reef inscribes chemistry for centuries into the skeletons we will drill and read years hence. Each new layer of sediment, thin as eyelid skin, holds the dust of our engines, the fibers of our fabrics, the soot of our fire. The ocean does not delay, it does not forget. It remembers even as we live. And yet, if the ocean will carry our memory no matter what, written in temperature, chemistry, and sediment, then perhaps the question left for us is softer still. Will the ocean remember us only for endings, or will it also remember that we noticed, that we wondered, that we tried to listen back to its silence as if it were speaking directly to us? For now, we arrive at the end of this long journey, one that does not conclude but dissolves gently into where it began. We return to the first current, the question whispered in the beginning. Does the ocean remember? If so, what is it remembering, and what does it mean for us to be remembered by it? The currents themselves offer the closest answer we may ever find. They move as water, but they feel like time embodied. Endless loops that outlast the rise and fall of mountains, immune to the brevity of a single life. A parcel of water sinking near the Arctic today may not emerge again until centuries have passed. By then, empires will have come and gone, languages will have flickered into silence, and landscapes will have been transformed by ice, by heat, by desert winds. The current will surface changed, but still carrying within it the faint isotope traces, the exact chemistry of the last time it touched the sky. Is this not what memory is? Not permanence, not clarity, but carrying forward a trace that shapes what comes after. To call these loops conveyors or circulations is scientifically apt but poetically insufficient. They are much more than physical plumbing. They are history in motion, diaries that are never shelved but endlessly rewritten. Deep currents hold the world's carbon for centuries before exhaling it. In doing so, they dictate whether forests flourish or wither, whether ice climbs across the continents or retreats. They bind the tropics to the poles, making one climate of the whole Earth, not perfectly equal, not without disruption, but always connected. Could it be that every breeze we feel on our face is the result of some choice made deep in the darkness below, some balancing in unseen water far older than our names? Maybe, maybe not. And yet the symmetry is undeniable. Water carries memory, and memory carries future. We have seen how sediments preserve catastrophes, how isotopes whisper of forgotten skies, how corals keep diaries in their skeletons, how even plastic and soot are now pressed into permanent strata. But before the sediments, before the fossils, before the isotopes and even the reefs, there were currents. They are the first archive. They distribute every element that other systems record. Storms, droughts, fertility, famine, all cascade outward from them. If the ocean is memory, then the currents are its handwriting. The handwriting is fluid yet precise, as invisible as wind, but as tangible as stone when passed through the slow ages of geologic time. Entropy reshapes them, too. They resist imbalance as long as they can, redistributing heat until differences blur, until contrasts grow small enough to fade. Yet entropy never fully erases them. The sea finds new balances, new loops, new circulations. Under conditions radically different from our own, the planet still found ways to circulate water, still found ways to breathe. This is memory again, reframed. Not specific records kept intact, but patterns that return despite forgetting, like themes played endlessly in variations over an unfathomable length of time. Perhaps the closest thing to eternity that exists on Earth is not the mountain or the glacier, but the rhythm of circulation itself. Slow, endless, revising, yet never without a pulse. So, how should we describe it? Breath is not too large a metaphor. The oceans inhale when waters sink, holding carbon and heat below, sequestering what the sky cannot contain. They exhale centuries later when those waters rise again, carrying not only carbon but the imprint of the ages passed in silence. To breathe is to live, and if Earth breathes at all, then it is the ocean's currents that expand and contract in a tempo beyond perception. A tempo that loops not in seconds but in epochs. Our breaths are finite, but the ocean's breath is inheritance itself. Consider how even our own lungs leave traces in the ocean. Every exhalation carries carbon dioxide, eventually drawn down by sea surfaces to be hidden away in deep waters. What we breathe out today, the sea may pocket and hold for 1,000 years, storing a fragment of us where no sunlight falls. The ocean remembers our lives not symbolically but chemically, not metaphorically but with iron and carbon and oxygen. Each one of us is written into its breath, carried forward. What if memory is less about the stories we narrate and more about the air we change, the molecules we leave behind? What if the truest mirror of us lies already in currents, swirling quietly far beyond our reach? This thought is both humbling and comforting. It strips away ego, reminding us that our permanence is small. We will not choose how we are remembered, only that we are. The proof rests not in monuments but in sediments, not in scripture but in molecules, not in archives of paper but in currents that comfort and unsettle by their sheer endurance. We are, all of us, already becoming the ocean's memory. Maybe, then, to ask, does the ocean remember? Is to misunderstand. Perhaps it is not that the ocean chooses to remember, but that it cannot not remember. Every wave, every evaporation, every drift of isotope is a record. The ocean does not decide what is valuable or trivial. It records everything indifferently, layering catastrophe and calm alike. In its mirror, there is no hierarchy. The rise of vast forests and the collapse of a plankton bloom carry equal weight. Our own footprint, so immense to us, becomes one more entry, strange perhaps, unique in its chemistry, but not singular. The ocean takes it all as it comes. Memory here is not loyal but constant. And yet, in that constancy there is something more. Patterns emerge from chaos. Heat recirculated becomes monsoon. Salinity shifts become thresholds between bloom and famine. Catastrophe becomes stabilization. Stabilization becomes oscillation. Oscillation becomes catastrophe again. It is a memory not of detail but of rhythm. The sea whispers not "this happened" but "this happens." Not because it has mind or thought, but because time itself carries repetition, entrainment, reflection. If meaning exists within memory, maybe it emerges there, in the echo more than the initial sound. It is possible the earth has always known itself this way, long before we thought to ask. The ocean is both mirror and lung, both archive and prophecy. It tells without language where we have been. It hints without intention where we are going. A species can persist without knowing the ocean remembers it, but not without being bound to that memory. History is freedom of choice above the surface, but below, the record is already kept, in temperatures, in currents, in sediments. If we return once more to the first current, to the thought that launched this journey, what do we find? That beneath silence, water moves. That its movement is not empty, but a remembering. That memory is never tidy or complete, but reflection, diffusion, layered secrecy. That the question, does the ocean remember? May be less about the ocean and more about ourselves. For by asking it, we admit to our longing, our fragile wish that we, too, might be carried forward, folded into enduring motion, written in some patient archive we cannot erase. And yet, if all this is true, if the ocean's current is not just physical motion but history itself shaping air and time, then the ocean is more than water. It is breath. It is mirror. It is memory. And as long as it moves, Earth will never truly forget itself.